Gauteng, grade 12 maths, paper 1, full memo. So that's what we're going through. Starting with question number 1, as mentioned in the other videos. The PDF file to all these questions, you can find that in the description. And then, yeah, if you need access to the online courses, you can also just find that in the description. So anyways, question number 1, so we can see it is pretty straightforward. They're asking us to solve for x. Solving for x in a situation like this one, you obviously want to be careful, because the moment you have two values of x on opposite sides of the equation, your best bet is to actually put them on one side so that you can actually factorize. I mean, like, you would have been maybe thinking to yourself, why don't I just divide by x on both sides? Yeah, that would work, but the thing is, you may not end up with two answers. In this case, doing this, you're likely to end up with two answers, because now you can take out x as a common factor. Taking out x as a common factor, you can clearly see that you have x plus 4 here equal to 0, of which you're able to say x is equal to 0, or x plus 4 equals to 0, of which, as long as you've said here x plus 4 is equal to 0, we know that you're going to end up with x is equal to minus 4. There we go. So that's an answer for x. Our next question, it doesn't seem like we're going to do anything crazy, because one way or the other, we are just going to use our calculator. So in our calculator, we just have to make sure that we put everything properly so that we don't like lose marks unnecessarily. So in our calculator, let's see. We'll have here our quadratic formula, x is equal to minus b plus minus b squared minus 4ac, the whole thing, over 2a. Now, all this being said, the only thing I can safely say is, I mean, like, the only way you're going to lose your 3 marks is if you don't put your stuff into the calculator properly, because there's really no reason to get this kind of a question wrong. So the other thing is, the moment you see that they're telling you to leave your answers with 2 decimal places, automatically 99.99% of the time, or actually 100% of the time in that kind of a situation, you will not necessarily be able to like factorize your question, meaning that your answers, you would only be able to get them using your quadratic formula. So in the quadratic formula, let's see here, our 2 answers, we're getting the x is equal to 0.62, or x is equal to negative 1.62. Perfect. Moving on to bigger and brighter things. This question reminds me of what's in the algebra course on our website. Just remember, I mentioned the link to that is in the description. So in the algebra course, one thing that stands out is questions like these, right? They low-key remind us of, the K method. But the only thing is, these two values, or these expressions under our surd here, they are not exactly 100% the same. So, oopsie, no K method here. But obviously, I mean, like, solving for x here, the other thing that I automatically thought of was the mark allocation. The reason I thought of the mark allocation is because I wanted to know how much thinking we need to put into this question. So for 5 marks, yeah, you can imagine you're gonna kind of have to do a bit of thinking over there, but you don't want to panic. The easiest thing to do is, when you're working with values that have square root symbols, right, try to have them on opposite sides of your square root symbol, because if you at least have them on opposite sides of your square root, of your equal to sign, I mean, if you have your square root symbols on opposite sides, right, like let's say one is on the left, one is on the right, it's much easier to like square one side and then square the other side, because what that does is, you see the one here, this square root cancels that, you just have x plus 4 here. Remember, the square goes for the top, which is a 16, and then for the bottom, the square root symbol, if you square it, it will just cancel out. So here you have x minus 2. That's obviously going to be worth a mark. And then now you can cross multiply, because, I mean, a fraction on one side and a fraction on the other side, you might as well just cross multiply. 1 times 16 is 16, and then these two multiplied by each other, it's just going to be 2 brackets next to each other. So that being said, let's see here. X times x, right, is like x squared. X times -2, there we go. 4 times x is like 4x. X times -2 is like -8. There we go. And then, I mean, here we might as well put everything on one side, you see. -2 plus 4 going to give you a +2. -8 plus 16 is, no, -8 minus 16 when you move it over. And then this is going to be like -24. Is that? Yeah. So here, you definitely may want to put this in your quadratic formula. See here, minus b plus minus b squared minus 4ac over 2a. And then as mentioned already, the only thing that will bite you in the buttocks when you use the quadratic formula is not substituting values correctly. So here a is a 1, c is a -24. This one I think we could have factorized, but yeah, that's the thing. I mean, on my side, the one thing I always use is the quadratic formula. Factorizing is like second option if I maybe think of doing it, but the quadratic formula kind of saved me, so yeah, our two answers, we have -6 in the calculator, and then we also have 4. But the thing is, normally when you work with questions that have square root symbols, always double check your answers, you see, by putting them in your equation, like the very first thing you were given. So if you put a 4, right, you would have there 4 minus 2, or rather just put it in the calculator. Let's actually just double check. If you put a 4 there and you put a 4 there, let's see what the calculator gives us. Yeah, the 4 is working out, it's giving us a 0. Let's try the -6. The -6 is not giving a 0, so this will have to cancel it out, you see, because it's not balancing the equation. Because if you look nicely here, -6 minus 8, I mean -6 minus 2 gives you a -8, and you cannot put a negative under a square root symbol. So oopsie, we have to disregard this. And now let's move on to the next question. Solving for x here, this is fortunately one of those questions that are not so difficult. The one thing I always say is try to see what kind of a quadratic equation you're dealing with first. And then once you have seen what kind of a quadratic equation you're dealing with, you can easily answer this question, because this is asking you, where is this expression going to be bigger than 0? So what we know is that, okay, let's multiply out our brackets here first. X plus 2, we're going to have to multiply out with -3x plus 1, right? X times this is going to give us -3x squared. X times 1 is going to give us x. This times that, -x. -6x, 2 times the 1 is going to give us 2. We don't have to solve for anything here. We're just going to see what kind of an equation this is. So the one thing we can already see is that it is an equation that has a negative parabola. So 1 minus 6 gives you a -5, and then there's a 2 there. Now the big idea is here, your expression will technically be a frowning parabola. Now the idea is, now you can easily work out where is this parabola having y values that are bigger than 0, because technically our question here is just asking us, where is the parabola above 0? You see, where is this above 0? We just worked with this expression here. So we're seeing here, where is our parabola above 0? So if we look at our graph, what we know is this here can act as the x-axis. So if we're going to work out where our graph is above 0, what we know is, I mean, visually, it is above 0 over here, you see. So we need to find out starting from which x value up until which x value. So to get those x values, we can just factorize this equation. You see, we can just factorize this equation. We can actually just get answers using our quadratic formula, you see. So minus b plus minus b squared minus 4ac, and the whole thing over 2a. A is a -3. So let's see what our two x-intercepts are. Because remember, as long as we have our 2x intercepts, we will easily be able to then say that it's above 0 from this x value until this x value. So the first answer in the calculator is a -2. The other one, x is negative. No, that's a positive value. Positive a third. So obviously the one on the left is the one that has -2. So we have -2 there, and then we have a third over there. So that being said, our answer can just be laid out now. So our graph is above 0 from where x is a -2 up until a third. So here you're going to say x is an element of -2 until 1/3. We're putting round brackets because they didn't say bigger or equal to 0. If they said bigger or equal to 0, then we would put square brackets over there because specifically at -2 is equal to 0. But then because they did not say anything like bigger than or equal to 0, we put a round bracket there. Same for this side, we also put a round bracket because specifically at -2 and specifically at 1/3, the graph is equal to 0. It's not above 0. It only starts being above 0 specifically just when the x values go higher than -2. That's when it starts having y values that are above 0 until an x value just before 1/3. So that is that. Let's move on to the next question. With the next question, right, for 6 marks, we really don't have to struggle too much, or we don't have to struggle at all, right? With the idea with simultaneous equation questions is your signs. So here I may want to make y the subject of the formula. So here 3 plus 2x is equal to y. So I decided to go this route because I mean, like, it's easy to make y the subject of the formula. Now we just need to throw y into the other equation. So here it is, you get 6 marks for just being careful, literally. So here 6x plus y. So we have to throw this whole thing in there, right? Just like 3 plus 2x and then squared. This is equal to 3 plus 5x, and then y there is just 3 plus 2x, right? 3 plus 2x. There we go. So all this being said, what do we now need? Remember, these two brackets, you can just multiply them out. So you have 4 here, 3 plus 2x, 3 plus 2x again, then you have equal to 3. So remember, I said you're getting marks for just being careful. So fun enough, as I'm talking now, I know normally when I like talk, well, I'm writing and talking, so a mistake is inevitable. But the idea is to just always double check what you would have written out. But anyways, let's see here. 3 times 3 is going to give us a 9. 3 times this plus 6x plus another 6x plus 4x squared. And then here, let's see. Skills of work. 15 plus 10 is like 25. So we have 25x. And then here, 6x again. So the good news is, as long as you take your time, you're likely to not mess up. 12x, because normally messing up happens when you try to write out or do too much in one single line. Just take it slow. But anyways, I think this we can take it to one side. This is going to be a -3 and -25x. And then this is equal to 0. And then let's see. So what do we have now? So this is going to be like 6x. 4 times 9, right, is like 36. So this is like 36. 4 times 12 is like 48. 4 times 4 is 16. There we go. -3 minus 25x equal to 0. And then, so you can see, obviously, the annoying thing with questions like these is they just drag on for so long, Gets a bit annoying, but it is what it is. Gotta do what you gotta do for your marks. So let's write this in ascending order or descending orders of powers. So let's see, 16x squared, we can write it first. So here now, 6 plus 48 minus 25. Let's see what that gives us. 6 plus 48 minus 25. That's giving us 29x. 29x. 36 here minus 3. 36 minus 3 is like 33. And then that's like what? 33 is equal to 0, right? Fine. Now, this is a nice quadratic equation. So we can easily just, solve for x there without being bothered. So solving for x here, right? I mean, like, as I'm looking at this, I'm thinking to myself, I know I messed up somewhere. Yeah, this is supposed to be, good Lord, let me see where I messed up. I messed up good. I can just feel it, man. I can just feel it. Plus 25. Oh, yeah. How did I get a 10 there? 2 times this. Yeah. Oh, yeah, squared. Oh, bugger. Man, this sucks. I was literally talking about making a mistake while making a mistake. That's kind of annoying. This is squared. So this would still be 15. Yeah. And then this would still be 15. Yeah, this is kind of awkward, but gotta take the L sometimes, just gotta take the L and just gotta be humble. So yeah, this would have been there. 15 is still there. This is would still just be there, right? Plus 10x squared. If you move everything to the left, right, here you would have minus 10x squared. And then here now, you would then have, you would still have your 15 over here. And then you'd still just have your negative 10x squared here. Oh, what a wow, man. This would actually be then 6x squared, and this would actually be 39. This would be a plus though. Yeah. So I think the good news is normally whenever I say what I say, whenever I talk about, this is the weirdest thing I've noticed with these papers. Normally when I talk about making a mistake, it's usually during a time when I'm actually making a mistake. It's like, wow, okay, that's awkward. But anyway, 6, let's just work out our value here. Plus minus b squared minus 4ac over 2a. So this is like minus b, right? Minus b plus minus b squared minus 4. A is a 6. C is a 33. And then your A value here is a 6. There you go. Perfect. So let's see what this answer is. What this answer is, what the values of x are in our calculator. In the calculator, getting negative 11 over 2. The other one, getting negative 1. So obviously, the moment you have your x values, it's easy to get the y values because you can just use the equation that you were given right at the beginning. So here, 3 minus y plus 2x, right? 3 minus y plus 2x. This is equal to 0. So the first x value, you can throw that there, right? It's like 3 minus y plus 2, negative 11 over 2. So the 2 cancels the 2 there. You're going to have here 3 minus y minus 11. And then the y goes over. 3 minus 11 is like negative 8. Huh. Yeah, y is going to be negative 8. The other y value, you're going to throw, remember, negative 1 over there, right? So it's going to be 3 y plus 2, negative 1 here. And then this is what? 3 minus y minus 2. And this is like y goes over. Y is a positive 1. So, yeah, I mean, like, those are the answers that we're getting. So, we might as well just get them. So moving on to the next question. It's 1 point something. What is it? It's 1.3. 1.3 says, oh, it's a nature of roots question. Is it? Yep. It says, given that this equation is equal to negative 4p squared. Okay. For which values of p will the equation have equal roots? So this question is not difficult at all, because remember, when it comes to you having equal roots, if you think of the way your quadratic equation is laid out, minus b plus minus b squared minus 4ac over 2a. The only time that you're going to have equal roots is when b squared minus 4ac is a 0. Because if this thing here is a 0, it means that whether you put a plus or a minus, your answer is going to come out as the same answer. That's how you have roots that are equal. So in our situation here, we just have to put this into standard form, and then we have to work out where b squared minus 4ac is equal to 0. So putting this into standard form, remember, I mean, the way it is, right? You have to remember that we would be asking ourselves, okay, fine, what's the main variable? Is it x or p? But here they said, given this equation, for which values of p will the equation have equal roots? So fortunately, remember, what you want to focus on is x is usually your main variable. So you don't want to think that here it's a different story. So what I'm trying to say is, when you're putting this into standard form, right, everything goes on one side. You have 9x squared minus 12px, and then here you have positive 4p squared equal to 0. Now, the way this is laid out, right, you have to be careful of what your coefficients are and all that. So here, remember, a quadratic equation in standard form has ax squared plus bx plus c. Now, a is the 9, b is negative 12p, c here is actually 4p squared. So with this information in mind, right, what we know is that we want to work out where b squared minus 4ac is equal to 0. So our b value, we said it's a negative 12p. Our a value is just 9. Our c value is just 4p squared. Perfect. So as you can see, we have a lot to do. No, not really. Question is practically done. So negative 12 squared is 144. P squared is just p squared. 4 times 4 times 9. Calculator, please do your thing. 4 times 9. That's like 144. So here we're going to have negative 144. And then we have our p squared equal to 0. So solving for p here, remember. Wow, no bloody darn ways. What? This thing just finessed itself. Or did it? O-A-C. Wow, this is saying 0 is equal to 0. Come on, man. Come on now. So obviously that's a bit annoying because, but it is what it is, you know. This minus this gives you 0. Now this statement is definitely true, right? This statement is definitely true. What this statement is practically saying is that it's literally saying that yes, our what am I saying? This is 100% fine, because remember, we wanted to work out values of p where this is going to be equal to a 0. Now this is telling us that regardless of whatever value of p that you put in, your roots will always be equal. That's what this is saying. So here we can say, therefore, roots will be equal for all values of p. There we go. The roots will be equal for all values of p. Question 2 says, you have a geometric sequence as simply put here. This sequence starts with 9.5, 9/2, and then 9, and then 18. So clearly everything is being doubled. So our common ratio here, we can clearly just have the 9 divided by 9/2. In your calculator, that's just gonna give you a 2. Because remember, your value of r is always T2 over T1, or you can say T3 over T2. That's 100% up to you. You'll still get it 2. So that's one easy mark there. 2.1.2 says how many terms are in the sequence. So for you to determine the number of terms in the sequence, all you need to find out is the position of this term in the sequence. Because when your sequence does not have just ellipses at the end, this is telling you where the sequence ends. So this is a geometry. So what you know is your geometric sequence has this as the general term. Our A is the first term, which is 9/2. 9/2. Our common ratio is a 2. Now remember, we want to work out the position of 2,304. So where Tn is, you can put 2,304 there. Then where n is, you can leave it open because we're trying to work out the position of this term, if this is the general term. Remember, this is like the standard format of a geometric sequence. So we can just put in our A and our R here, and then the value that we actually have, and then we can find its position. So solving for n, remember, you can see here, don't make the mistake of multiplying this. You cannot do that because of the exponent here. What you want to do is to get rid of the 9/2 first. And you can easily do that by dividing by 9/2 on both sides, of which the answer that you get on the left side of the equation, you can just get that from your calculator. So 2,304 divided by 9/2, this is going to give you 502. And then here, these cancel each other out. The ones on the right hand side here, these are going to cancel each other out. This, and you have 2 to the power of n-1. Let us our fallen comrade. So moving on from here, right? If you're going to work out your value of n, you're going to have to use logs. Whenever you use logs, you isolate the exponent, and then whatever the base of the exponent was, we make that the base of the log. This number is still just going to be there. Of which this, you can fortunately put it all in your calculator. So in the calculator, log 2,512, that's going to give you a 9, and this is n-1. The 1 goes to the left here, you have 9 plus 1, therefore your n is a 10, you see. So what you know is that you have 10 terms in the sequence. So you can even say here, therefore 10 terms. If you just left it off here, that's 100% fine. Let us move on to the next one. The next one says 2.2, right? Let me actually highlight this a bit because here, this is our infinity symbol. This is saying k is equal to 1. So with this given, right, and then this is saying k minus 1. There we go. So with this information given, you have to remember that it says given this equation, or given this expression rather. Well, it's an equation because there's a left side and the right side. Given this equation, right, they say that we should determine the value of m. So when it comes to sigma notation questions, the one thing you want to remember is they are already giving you all the information you need just by giving you this expression. So the idea is, as long as you see here the variable you're dealing with, the variable you're dealing with here is a k. As long as this k is an exponent, it means that you're dealing with a geometric series. You see, as long as your value of k is an exponent, you're definitely dealing with that geometric series. So because we know we're dealing with the geometric series, another way we could have spotted that we're dealing with the geometric series is the infinity symbol. because you only have a sum to infinity if you have a geometric series. So what this is telling us is, in your geometric series, right, as long as you're dealing with a sum to infinity question, you want to remember that your value of r will always be between 1 and -1. So what that also means is, anytime you see sigma notation, remember sigma notation needs you to use an SN formula, a sum of formula. So the sum of formula that we can use is the sum of formula for a geometric series. Now we can use the version where the 1 starts and then the r follows, because anytime you're dealing with the sum to infinity, this is the version you want to use. Because remember, you have two versions of your SN formula. Both of them work, but then for the sake of performing calculations, right, the one with 1 first and then r afterwards, you may want to use that for cases where you're dealing with sum to infinity. It makes it easier for you to like work out things and simplify your equation and all that. So with everything being said here, a sigma expression tells you that you're adding stuff up. So the moment you think of this, right, you're immediately gonna disregard this formula, mainly because of the sum to infinity symbol. Because when you will be thinking to yourself, okay, fine, there's sigma there, so I should think of an SN formula. Thinking of this obviously is not going to work, because you would be asking yourself, okay, fine, how many terms are you adding up? You don't know. So since you're going to infinity, the only viable option is the sum to infinity formula. So you'd automatically be thinking of this formula once you see this expression. What you're now seeing is you're adding up terms from the first one up to infinity. This is the general term, and the sum to infinity is at 12. That's what this expression is saying. Because remember, all sigma expressions, they have three things or three pieces of information that they give you just from what will be written out. So you see there's a sigma symbol here. At the top, you'll always be told where you're ending. At the bottom, you'll always be told where you're starting. And then here, you'll always have the general term. General term. So this sigma expression will always be telling you that you're adding stuff up, starting somewhere, ending somewhere. And then it will always be equal to whatever you would add up stuff to. So because ours has an infinity symbol at the top, we know that this 12 here is the sum to infinity. Sum to infinity. So without overthinking it, you see, it's just a 2-mark question. So this 2-mark question, they've given you a general term there. They've given you the sum to infinity, and they want you to find m. So if you're going to find m, the one thing you obviously want to think to yourself is, okay, fine, in this equation, right, you have something to put here. So you obviously need to have something to put there and there. If you can just put values here, you know that one or the other, you will be able to work out m. So for you to figure out what a is, and then eventually what r is, I mean, the format here is not really complicated. It's exactly like what a geometric general term looks like. Remember, a general term of a geometric series will always have a here, and then r here, n minus 1, which is exactly the format here. Remember, n is just a placeholder. So just by looking at the general term here, you can understand why this is a 2-mark question. It's a 2-mark question because the 6 here is our a value. The m is the r value. So you really don't have to do much for you to find what a is and what r is. So in your sum to infinity formula, what you already know is the sum to infinity, our value of a, we said it's just a 6, because where 6 is, that's where a would go. That's 6 over there. And then our value of r, we can see where m is, that's where r would go. So our value of r is m. Solving for m here, we know that it's just a fraction on the right. So we can make this a fraction as well on the left, and then we can cross multiply. 1 times the 6 gives us a 6. 12 times this, we can just be careful and make sure we put that in brackets. And then we can multiply inside the brackets, like 12 times 1 is a 12. 12 times negative m is negative 12m. And then here we need to solve for m, right? So we can take the 12 to the other side so that it's a positive. And then here 12 minus 6 is a 6. 12m like that. Divide both sides by 12. our m is a half, as expected, because remember, m here is representing the value of r, and we did say that as long as you're dealing with sum to infinity, your value of r has to be between -1 and 1, meaning it has to be a fraction where the denominator is bigger than the numerator. So that's an easy 2-mark question. Now we can move on. Let me just double check if there are any questions. Nope. So 2.3 says, for 5 marks, the third term of a geometric series is 18, and the fifth term is 162. Determine the sum of the first 7 terms where r is smaller than 0. So these questions, you don't want to overcomplicate it. These are the kinds of questions you read once and then you're like, okay, fine, and then you have to read again while making notes. So as you read, you have to write something. They said the third term. So the third term translated just means T3. T3 of the geometric series is 18. Remember, is means equal to. So this is the information they gave you. T3 is equal to 18. Here, the fifth term, T5 is equal to 162. Before you carry on, you need to be able to always know what a sequence looks like without you having numbers. So what I mean is a geometric series always has A here, and then the next term is A times R, and then the next term is like AR to the power of 2, and then the next term is like AR cubed, going on and on and on. So you always need to be able to visualize what a term is when you actually don't have its actual value. So this is what T1 is, T2, T3, T4. If you can always do that, you'll be unstoppable, because when you see things like T3 is equal to 18, what you already know is T3 can just be written like that, meaning here you can just write AR squared is equal to 18. T5, you automatically know it's just AR to the power 4, and you know this is equal to 162. So this one statement has given you these 2 pieces of information. It's clearly 2 equations where those 2 equations have A and R as your only variable. So if you read some more, they want you to determine the sum of the first 7 terms. So them asking to determine the sum of the first 7 terms. Clearly you would then ask yourself, so they're asking for S7, where R is smaller than 0. So whichever way, if T3 is 18 and T5 is 162, our sequence is clearly getting bigger and bigger. So the SN formula that we can think of is this one, R minus 1. Because if it was getting smaller and smaller, the SN formula we would be thinking of is this one. But anyway, so the information they've given us is 1, 2, and then 3. So they're asking for S7, right? Determine the sum of the first 7 terms where R is smaller than 0. So this, you can use it more as something that can be referred to when you're done with your question, because this is almost saying we're probably maybe going to get 2 answers. We just have to pick the one that has a negative value of R. But we'll see. We don't want to overthink it. So you can see here, if we're going to get the sum of the first 7 terms, right, which is S7, for us to work out S7, we have to have the value of A, we have to have the value of R. I mean, for S7, N would just be a 7 anyway. So, you know, this we already have. So clearly you can see from the information they gave us, we need to get A and R first. And because they gave us 2 equations that both have A and R, we can use those 2 equations to work out A and R simultaneously. So let's do that. Working out A and R simultaneously is not going to be a hassle, because here we can we can easily just isolate A here. If you isolate A here, you're gonna have A is equal to 18 over R squared. That's equation 1. And then whatever this equation is, you can just throw that into the second equation. You see, because that's how substitution works. If you throw this information in the second equation, you're gonna have where A is, you can have the 18 over R squared. And then that whole thing is being multiplied by R to the power 4. Let's just put this over 1 like that. This is 162. The reason I did this is so that you can see that at the top here, 18 times this is going to give you 18 r to the power 4. At the bottom, r squared times 1 is just going to give you r squared. And then what we know is the right hand side, nothing has changed over there. So this, we know 2 of these cancel 2 at the top. You have 18r squared. And then here we're clearly about to get a value of r. We can just divide both sides by 18. And then we can then eventually square root both sides. So here, I don't have to put this in the calculator yet. We can just put everything all at once. So here, let's see. Remember, they told us r has to be smaller than 1. So when we put this under a square root, we don't have to put plus or minus. We can put plus or minus, but we have to choose the negative value as the value of r, as they have just told us there. Of which in the beginning, we did mention that we're likely to get 2 values, and then we just have to pick whichever one is negative. So here, 2 answers, but we have to pick one that's negative, because they said here r is smaller than 0. Since we now have r, we can easily get a by using the second what? By using the second equation, or whichever way, as long as you have r, you can use any equation to get a. Even this one, let's put r there. So in the first equation, if you put r there, which is a -3, this is just going to give us 9a. And then divide both sides by 9, you can have a is equal to 18 over 9, which is just a 2. If you divide both sides by 9. So we have a, and we have r. So we're good to go. So we can easily work out what S7 is. So working out what S7 is, we can see here S7 is going to be equal to a is a 2, r is a -3, and then what you may call -1 here, -3 minus 1. All this in the calculator. Let's see what we are going to get. So there's a 2 here, brackets, and then we have like -3, the whole thing to the power of 7, and then minus 1, and then we have the -3 minus 1. So this is all good, all nice, nothing crazy. The final answer here is 1094. So we would not necessarily be expecting something too big, because remember, if your value of r is a negative, it means that your values are alternating. You're going to have positive numbers and then a negative one, a positive number and then a negative one, going on and on and on. So if you add them up, obviously you'll have a couple of positive numbers that are big and a couple of negative numbers that are like super small. So when you will add them up, you're not going to end up with something very big. That's for 9. That's for 2.3. 2.4 says the general term of a quadratic number pattern is given by this. And then he says here, and its first term is 8. Okay, the general term of the first differences of the pattern is tk equal to 4k minus 2. For 3 marks, they said, determine the next 2 terms of the quadratic number pattern. So this is the kind of equation where you read it once and then you have to, make a sketch, or you have to write stuff out. They said here, we have our general term. The first term is an 8. So we know you just have an 8. The next term you don't have. And then the term afterwards you also don't have. I want you to work those out. What they have given you, though, is the general term for the sequence of first differences. What that means is, remember, all quadratic number patterns have a sequence of first differences. Like whatever this is minus this is what goes here. This minus this is what goes here. And then in addition to that, what we know is all quadratic number patterns have a second common difference. So this 4k minus 2 is going to give us this number over here, and then also this number over here, of which that's useful to us, because as long as we have these 2 numbers here, we can easily work out what this value is. We can easily work out what this value is. So here the only thing we have, as we said, is just our 4k minus 2, and then here also 4k minus 2. So for us to get whatever is in this position, we can just put 1. Okay, for us to get whatever is in this position, we can just put 2. So let's do that. In the sequence they gave us, let's put T2, where K is, we can just put it 2 over there. Why am I doing 2 first? Should have just done 1 first. But anyways, let's just see what these answers are. So the first one, this is going to be 2 times 4, which is 8. 8 minus 2 is going to give us a 6. So what we know is the number that goes there is just a 6. Put a 6 over there. Oh, no. This is why I should have just done what you call the first one first. Because now I'm like, bro, come on. So this for T2, that's going to go there. For T1, that's going to go there. This is like 4 times 1, which is our 4, minus 2, that's a 2. So we know what these numbers are in the sequence of first differences. Now remember, the numbers down here, right, can help you generate the sequence, because all we know is 8 plus 2 gives you this number. And then 10 plus the 6 gives you this number, you see. Because when you're working backwards, right, you would technically have said 8 minus the 10 gives you the 2. 16 minus the 10 gives you the 16. So as long as you have these numbers down here and you're working from the first one, going on and on and on in your sequence, you're going to have to take this plus this, get this value, plus this, get this value, going on and on and on. So here what we can now say is, therefore, in our main sequence, right, T2 is 10, T3 is 16. That's why this is just a 3-mark question, because they know that this formula here is what's supposed to help us generate these values. For 2.4.2, it says, hence or otherwise, show that the general term of the quadratic number pattern can be given by this. So this is not a difficult question, because what we know is we have the sequence already. So this is why you don't want to mess up in the beginning, because, you know, some of these questions, they'll come back to bite you, because now if you got the first question wrong, now you're losing marks here, you see, because you won't be able to answer this. But anyways, our sequence, we said there's 8, 10, and 16, right? And then, since it's a quadratic number pattern, what we know is the second common difference here is just 6 minus 2, which is a 4. As long as you have these 3 levels, you can easily work out your general term, starting from the bottom. From the bottom, you make it equal to 2a. This, you make it equal to 3a plus b. The last one, you make it equal to a plus b plus c. Perfect. So with all this being said, from the bottom right, you know that 2a is equal to 4. You start there. So it's like 2a equal to 4. You're going to divide both sides by a 2 here. The value of a is going to be a 2. The next stage here, your a, you have it now. It's a 2. Make this equal to a 2. Working out a value of b here. This is 6 plus b equal to 2. The 6 goes to the other side. You're going to have 2 minus 6, which is like a minus 4. And then lastly, a here is 2, right? So it's like 2 here minus 4. The c value is just a c equal to 8. Working out a value of c, there's 2 minus 4 here, right? So that's like minus 2. And then the minus 2 goes to the other side. You're going to have c plus 8 plus 2, which is a 10. So all this is promising, because you see negative 4, positive 2, positive 2, and then positive 10, positive 10. So here we can then say, therefore, Tn is equal to 2n squared minus 4n plus 10. Then you get your 2 marks. Your 3 marks. Then you move on. 4.3 here says, which term in the quadratic number pattern is equal to 3050? So that's more like a bonus mark. So it's more like, if you get a mark right in the beginning here, it trickles down to the rest. But if you lose a mark right at the beginning here, you lose all of them. But at least here, you would at least be able to get the 3 marks, because you have the formula already. So T, we don't know what term this is. So Tn, right, is, hold on. We have the Tn formula already. This is the actual term. So where Tn is, we have to put 3050 over there. We don't know its position, but that's what they're asking for. You see, which term in the quadratic number pattern is equal to 3050? So we're solving for n. And clearly, if we're going to be solving for n here, we can just use the quadratic formula because this is a big number. So we have 2n squared minus 4n, 10 minus 3 or 50. And then that's going to give us what? 0 is equal to 2n squared minus 4n. So this is 10 minus 3 or 50, right? So that's going to give you negative 3040. This, I mean, you could think to yourself, let's take out a negative, let's take out a 2 as a common factor. You really don't have to. You just throw it all in the quadratic formula the way it is. I normally always just do that because there's really no need to take out anything as a common factor. The quadratic equation can handle anything that you throw at it. So when you're going to be putting stuff in the quadratic formula, obviously you want to make sure that you don't just put stuff randomly. You want to just check nicely to make sure you don't do, you don't make a mistake. But the thing is, mistakes are inevitable. So the one thing you actually just need to do is to always just double check what you write. You can't necessarily avoid mistakes. You can, but the fact of the matter is, in as much as you can try to avoid them, just know they're unavoidable. Just embrace them. And the one way to embrace them is to not fall victim to them. And the one way to not fall victim to them is to just always double check. So let's see. I'm busy saying double checking them. Yeah, let me double check. Everything here seems fine. I think I left out this bracket here. So let's do that. And let's put this in the calculator. Negative 4, negative 4 squared. There we go. You see, this is an error. I don't know why I put that there. But yeah, double checking. As I was saying things about double checking, I was busy making a mistake. But I think that's because as I'm talking, I'm writing. So I think that's how I usually end up finding myself making quite a lot of errors. But it's okay. It's okay. Let's see here. Everything in the calculator here, we're getting n as 40. So my assumption is the next answer is probably not valid. It's probably going to be like a negative or a decimal of some sort. And yeah, we're getting n as negative 38. But we have to disregard this one because we cannot have something in position negative. So anyways, question 3 here says, right, the figure below represents a pattern of shaded triangles. And then they say it here, yeah, it represents a pattern of shaded triangles placed on a white rectangular board. Oh, well, it's fine here. Then it says here the triangles all have equal bases of 4 units in length. So this is 4 units, 4 units, 4 units, 4 units, going on and on and on. So they told us here that everything from start to finish here adds up to 104 units. So we can actually easily take 104 divided by 5 and then work out how many triangles we have in total. So here then says here, the height of the first triangle is 1 unit. Each triangle's height thereafter is 1 unit more. So this is 1 unit and then 2, 3, 4 going onwards. And then it says here, for 1 mark, determine the area of the first triangle. So clearly determining the area of the first triangle is not a hassle because the base, we know it's 4, the height is a 1. So the area of a triangle, remember, it's just half base times height. So the area here is just going to be a half multiplied by the base multiplied by the height. So 4 times a half is just a 2. And then you can say here units squared. Squared. Perfect. And then the next one, let's see what the second question is saying here. The second question out of 2 says determine the area of the 26th triangle. So getting the area of the triangle in the 26th position, one thing you can already remember is the triangle in position number 1 has a height of 1. The triangle in position number 2 has a height of 2. The triangle in position number 3 has a height of 3. So somewhere along the lines, the triangle in position 23 has a height of 23. and then the one in 26 has a height of 26. So already what you know is the area of this triangle without even needing a formula is just going to be a half. The base we know it's a 4. The perpendicular height is going to be 26. So what we now know is, let's put all this into the calculator. A half times 4 times 26. This is giving us 52. Excuse me. This is 52 units squared. So obviously these easy questions, they lead up to something. 3.3 says here, the triangles are placed on a rectangular board, okay, with a length of 104 units as shown above. Determine the area of the unshaded part of the white rectangular board. That is the area of the part not covered by the shaded triangles. So they want us to get the area of everywhere else except for the triangles. So this one is actually not going to be a difficult question at all. It's a 5-mark question because we're just going to do a bit of writing. So the easiest thing you want to do for yourself is, remember, this is what you have. You have this rectangle here, right? And you have these triangles. You see, the heights go up to wherever. So if you're going to work out the area of this part that is like not shaded, don't focus on that part because you can't work it out directly. What you actually just need to do is to get the sum of all the areas of your triangle here and then remove it from the area of your rectangle, because you're going to take the area of a rectangle, the entire area, and then you're going to subtract the areas of your triangles, and then what you're going to have left is the area of the part that is not shaded. You see, so the area of the part that is not shaded would be this part here. You see, oh, I was trying to draw the triangles nicely, but hey, yeah, you see, that's the part you're gonna have. The part you're gonna have from taking the rectangle, minusing this area of your triangles, whatever is gonna be left is this, you see. So that's how we're gonna do it, because inside the area of our rectangle here, remember you do have the areas of your triangles. So if you take the whole thing minus the area of your triangles, what you're gonna have left is the part that they're referring to. So to do that, we clearly just need, the area of the rectangle is easy. Let's get that first. The area of the rectangle, remember from here all the way to the end there, they told us it's 104. So for us to work out this distance here, we have to know how many rectangles, how many triangles we have. Because as long as we know the number of triangles that we have, we will automatically know what this height is. See, because remember we already saw here that the height of each triangle is giving us the position of that triangle. So our job here is not difficult at all. We just need to find out, in a space of 105 units, how many of our triangles do we have? 104 units, how many of our triangles do we have? So let's do that first. So if we take 104, I'm gonna divide it by 4. Let's see what we get. 104 divided by 4, we're getting 26. Oh, okay. So we're certain that there is 26 triangles. So if there are 26 triangles, we know that the height here is 26. Perfect. So what we know is the area of this rectangle here is just gonna be 104. Yeah, bo.
Why did you divide by 4?
So the reason we divided by 4 is because each triangle, the base is a 4. So if the whole thing here is 104, but then each triangle is like 4 units, 4 units, 4 units, 4 units, 4 units, 4 units. For us to find out how many triangles we have, we can just take 104 and then divide by 4 units, because that's how many triangles we will have from the start here to the end of it. Does that make sense?
Yes, thank you.
Perfect. So let's see. So we now know we have 26 triangles. The area of our rectangle here is easily going to be 26 times 104, which is just going to give us, let's see in the calculator here, 26 times 104. This is giving us 2,704. 2,704. That's the area of the whole rectangle. So now we need the area of all the shaded triangles put together. To get that, we can just use a sequence. Our sequence has to clearly have the areas of our triangles so that we can then use the sum of formula to work out the combined area of all our triangles. So our sequence would technically have the area of the first triangle, right? We know it is, what is the area of the first triangle? It's just, we worked it out to be 2 units. So the sequence would have 2. The second triangle would technically have 2 times, it would be a half, and then a base is 4, perpendicular height is 2. So it's like 8 times a half, which is a 4. The third area, I just want to have 3 so that we can easily work out the sequence. So here the third one would have a half, the base is a 4, the height is a 3. So this is 12 times a half, which is 6. So automatically here we can see that this looks like it is an arithmetic sequence. So fortunately, if it's an arithmetic sequence, I mean, we know that these areas, they are going up to wherever they are going up to, but it doesn't matter. We want to see how much all these areas would add up to if we add them up until the area in position 26. So to do that, we can just use our SN formula. In our SN formula, right? Remember our SN formula looks like this. N over 2, 2a plus n minus 1d. So our common difference here, we can clearly see it's just a 2. The value of a is just a 2. And what else do we need? Our value of n is going to be 26 because we found out that we're dealing with 26 triangles. So in our formula here, S26, we have 26 here over 2. That's 2 here. N is a 26. D is a 2. So all this that we're doing, you can see we're not doing any heavy lifting at the moment. I actually don't know why I'm running out of space because I'm writing way too big. But anyways, so let's get the sum of all these areas of these triangles here. Fraction 26 over 2. And then 2 times 2, and then plus 26 minus 1, and then 2, blah, blah, blah. So this is 702. 702. So with 702, that's the area of all the triangles. So we have the area of the rectangle, the area of the triangles. We got it as 702. So you can clearly see that our sum is complete. Here we can then say, therefore, we're just going to say, take our 2,704, subtract this 702, and then we have the answer that they are looking for. 2704 minus 702. That's going to give us 2002 units squared. Squared. There you go. That's what you're going to do or that's what you would have done for this question. Nothing crazy, nothing major. Question number 4. It says here, we're given a hyperbola. We want us to give the domain. Now remember, the domain of hyperbola is always going to be x as element of R. However, you always need to say that x cannot be equal to the opposite of this value. Because remember, if you're ever going to sketch this graph, your x asymptote is where x is a positive 2. So somewhere at positive 2, you have an asymptote. And then here, this plus 2 is going to give us a y asymptote. Now remember, with asymptotes for your hyperbola, for the x, you always take the opposite of this one. But then for the y asymptote, you always take this the way it is. So you see this here is like a 2, this is like a 2. And this is a positive value. So your graph would have a shape here, and then it would have one over there. The reason for that is going up it's plus, going to the right it's plus. You see, so plus and plus gives you a positively gives you this shape here. It's an increasing, it's a decreasing graph, but it's fine. But the whole idea is, you see, this a value is a positive number. So remember, going upwards, those are positive numbers. Going to the right, those are positive numbers. So you have a curve there. And then going down is negative, going to the left is negative. So having a curve here, you see it's negative and negative, which is supplementing this value of 8 there. Anyways, without saying too much, let's move on to the next question. Oh, wait, no. We said x is element of R, but x cannot be equal to 2. Because your graph is not going to touch positive 2. X is element of R, but x cannot touch a 2. If you were asked for the range, you would say x is element, y is an element of R, but then y cannot be equal to 2. So moving on. I want us to get the y-intercept. Getting the y-intercept, remember, you just make x as 0 in your equation. So in this equation where x is, we're going to make it as 0. And then we're going to have here 8, 0 minus 2. We have 8 divided by negative 2, right, which is going to be negative 4. Negative 4 plus 2 is going to give us negative 2. And then if you look nicely, yeah, our y-intercept is at negative 2. But this is not to scale, so let me actually try and maybe finesse it a bit so that I can make it to scale. So if our y-intercept is a negative 2, maybe our curve would look something like that. Well, let me just remove this completely. I feel like we're actually eventually going to need to sketch this graph, which is like, okay, interesting. We kind of have an idea of what it looks like. So, yeah, the y-intercept is at 2. So let me put this here, because remember, if you leave it like this, this is a coordinate, you see. So you can leave it like this, or you can just say here, 0 and negative 2. So let me just double check. Yeah, everything looks fine. Nothing crazy. The x-intercept, we make y as 0. So in our equation of our hyperbola, we make y here as 0. If you make y as 0 here, you can just now solve for x, right? This is like 8 x minus 2 plus 2. Move this to the left, you can have negative 2. Then here you have like 8 x. There we go. So let's see here now. Just move to the left, right? Fine. Now remember here you have to cross multiply. Cross multiplying, you have like 1 times 8, which is 8. This times negative 2 is what you have, right? And then let's multiply inside. Negative 2 times x is negative 2x. Negative 2 times negative 2 is going to give us a 4. And then, what else do we have now? We have, yeah, we can just solve for x. The 4 can go over. It's going to be like negative 2x is equal to 8 minus 4 is a 4. Divide both sides by negative 2. Wow, negative 2 also. This doesn't make any sense all of a sudden. Oh, it does. Because you see, there's a y-intercept here of negative 2, and then there's an x-intercept here of negative 2. Oh, perfect. Okay. So you see, if you know how your sketch looks, these things make sense. And these are supposed to be symmetrical. So let me try and make this curve, a bit more like, this is all not necessary really. It's just, me being extra. But anyways, here we are. Let's see. I do feel like, boom, they're asking us to sketch the graph. So you have your Cartesian plane here, so, and then we already said your x asymptote is going to be a positive 2 because you take the opposite of this. So somewhere at positive 2, you're going to draw an asymptote. And then for the y asymptote, we already said you take this as it is. So that's a plus 2. So let's put that there. There we go. Now we have our x-intercept and our y-intercept. So already we know it cuts here somewhere at negative 2, and then it cuts here somewhere at negative 2. So remember, what we do know is our curve, right, has to, hey, come on, Brody, come on now. It has to come something like this. This is what it's going to look like, the one part, and the other one automatically has to be like somewhere there. You see, we said, fortunately, as long as you can see that that's your x and your y-intercept, it's easy for you to draw the shapes. because I mean, like, obviously this has to be one curve, and then at the moment you have one curve here, the other one has to be up there because these are symmetrical. And we said your value up here is what tells you where you put your curves, because if this was a minus, then you would put your curve somewhere there and the other one over there. Let's just label this graph. This here, we're labeling it f of x. F of x. Nothing crazy, nothing major. You get your 3 marks and you move on. 4.4 says, if y is equal to negative x plus k is an equation of the line of symmetry of f, determine the value of k. So this question is not difficult at all, because remember, whenever you're dealing with a hyperbola, it has a line of symmetry, you see. Now, the line of symmetry will always, it has two lines of symmetry actually. There's a positive line of symmetry and a negative line of symmetry. Actually, let me not even use this sketch. Let me use this one that's a bit nicer. Just copy this, make it a bit smaller. So with our sketch here that we have, right, what we need to remember is that, as we said already, right, a hyperbola always has two axes of symmetry. So our first axis of symmetry will always have a positive gradient. The other one will always have a negative gradient. Now your two axes of symmetries will always pass the point where your asymptotes meet. So all this kind of information is the kind of information that you definitely get in things like the functions and graphs course on our website, you see. So obviously the link to that is in the description. Did I not? Ah, wow, bro. You couldn't even write bright properly. Dogo. This is annoying, man. Like, what? I didn't even write bright properly. And it's like everywhere, bro. Look at this. Dogo. Man. It is what it is, man. Sometimes you win and sometimes you learn. But anyways, you have two lines of symmetry, right? One has a negative gradient. The other one has a positive gradient. Now, they are talking about the line of symmetry that has a negative gradient, because one thing we know for sure is the gradient will either always be a positive 1 or a negative 1. So since we're talking about y is equal to negative x plus k, this is the line that we're talking about, right? Y is equal to negative x plus k. The fortunate thing is, remember, we said the line always passes through the point where your asymptotes are. So, I mean, the point where your asymptotes meet, you see. So here there's a negative 2. It's a positive 2 and a positive 2. That's why it also passes here. But that's not very important. For we have a coordinate that the line passes through, right? So you can easily get k that way, because you know that it passes through a y value of 2 when it also passes through an x value of 2. So all this being said, move this to the left. You're going to have 2 plus 2, which is a 4. Then you have your value of k there. So the equation, therefore, y is equal to negative x plus 4. And that is the way we like it. So let's see here for 3 marks. It says determine the equation of the graph which is formed if f is shifted 3 units to the right and then reflected across the x-axis. So this kind of an equation, you can always just get it by firstly writing out what f of x looks like. This is what the equation of f of x looks like. So what we need to do is we have to just implement these things here one by one. So if f of x is moved 3 units to the right, if f of x is moved 3 units to the right, wherever x is, we would need to minus a 3. So wherever x is, you see where x is, you put the x minus 3, and the minus 3 is just there. So when this first step is executed, the equation will look like this: 8x minus 5 here plus 2. This is when it is just moved 3 units to the right. Now the idea is, when the graph is now reflected about the x-axis. Remember, this is where the x-axis is. So what you want to recognize is when a graph is reflected about the x-axis, what happens is that positive y values become negative y values and vice versa. So remember, since it's the y values that are affected, what happens is when you multiply, when you shift a graph or when you reflect a graph about the x-axis, you have to multiply the entire graph by a negative, you see. So this is telling us that the graph would be shifted 3 units to the right. And then after you move it 3 units to the right, you're going to have to multiply everything by a negative. You see, so multiplying everything by a negative, you would be seeing, let me just do this. Let me actually put this like this. You see, when you multiply everything by a negative, your whole equation here gets multiplied by negative, right? So seeing that in action, you would have the negative 8 and then x minus 5 down there. And then here you'd see negative 2. So remember, when you're dealing with a fraction, if you're multiplying something inside or multiplying something onto the fraction, you always deal with the top part. So anyways, it is all good. This will be the equation, you see. So here, determine the equation of the graph. Yeah, this is what the equation would look like, you see. The whole entire equation would be multiplied by a negative, and then everything would be moved 3 units to the right. So you see, we said it's easier for you to just execute the steps one by one. You see, shift to the right first, see what it comes out as, and then reflect about the x-axis. So we multiply everything by negative. If it was reflected about the y-axis, then remember, positive x values become negative x values, and then negative x values become positive x values. So meaning if a graph is reflected about the y-axis, wherever x is you put, you multiply this with a negative. You will just have minus x over there. So remember, again, all this is on the course platform. The link to that is in the description. It says here clearly the graphs of f of x. So we can easily see that f of x is a parabola because of this. So obviously this is telling us that the turning point is going to be -1, coordinate -8, because for the x value of the turning point, we always take the opposite of this. The y value of the turning point, we always take this number as it is. This is clearly an exponential graph, so that's all good. They say these two graphs are represented in the sketch below. And then they say P and Q. There is P over here. There is Q over here. These are the x-intercepts of F, and R is the turning point of F. So there's R over here. We already know what the coordinate of R. It's going to be -1 and -8. And you can see this is already on the negative side of our Cartesian plane. And we know for sure it's -1 because of this value here. We said for the x value of the turning point, you always take the opposite of this value. So already here, we can already see that the x value here is going to be -1. And then here they said A is this coordinate. It is a point on the graph of G, which is our exponential graph. All nice, all dandy. For one single mark here, they said write down the equation of the axis of symmetry. So getting the equation of the axis of symmetry is also something we already have here, because the axis of symmetry will pass through the x value of the turning point. Now, its equation will be based on the x value that it cuts, because this is a vertical line going straight down. So the equation of a line like this one, you'll always say x is equal to whatever x value it is cutting on the, what you may call, on the x-axis. Let us re-add our fallen comrade, and then we shall carry on. Admit, let me just help you out here. Ha ha ha. So let's see. With the next question, right? It says here, write down the coordinates of R. We already mentioned what the coordinates of R is going to be. It's going to be -1 because of this. We take the opposite, and then this we take it as it is. So here we're gonna say R just -1 and -8. Because remember, this format here is in the form y is equal to a x minus p squared plus q, you see. So your p value, the opposite of this thing here and this as it is, this will always be your turning point, you see. So that's why we have R immediately. That's why it's also a 1 mark question. They want us to now get the coordinates of P and Q. P and Q are the x-intercepts of our graph of F. So remember, for you to get the x-intercept, you have to make y 0. So this is our equation of our graph, right? F of x is equal to 2x, is equal to 2, and then x plus 1 here, squared, and then minus 8. So we have to make this equation equal to 0 because we're trying to solve for the x-intercept. So for you to end up with 2 values, right, or 2 answers, you have to be careful here, in the sense that here, this square here, you want to be careful when it comes to getting rid of this. So for now, we can take the 8 to the other side. It becomes a plus there. And then we can divide by 2 on both sides. Dividing by 2 here, dividing by 2 there. Here, 8 divided by 2 is a 4. And then here, these 2 cancels these 2. Then you have x plus 1 here squared. Now, the big idea here is that when you're going to get rid of the square root symbol here, this is where you need to make sure that you end up with 2 answers. Meaning if you square root this side and you square root this side, here this square root is going to cancel that. But then here, you have to have 2 answers. You see, plus or minus 2. And then since you now have plus or minus 2, it means you need to split up your page. One side, you work with the positive 2. The other side, you work with the negative 2. You see, that's how you're going to get 2 of your x-intercepts. So here, 1 goes to the left. Then you're going to have 2 minus 1 there. And then x has a positive 1. Here, the 1 goes to the left. Here, you're going to have a negative 3. Which definitely kind of makes sense, because if you have a negative 3 here and you have a positive 1 there, it's a valid answer, because remember, from your axis of symmetry until one x-intercept, the distance here should be the same on the other side. So you can see here, this is like 2 units apart. You see 1 unit, 1 unit. Same here, you see 1 unit, 1 unit, because from negative 1 all the way to negative 3, you're going to go 1 unit and then 1 unit, you see. Here, you're going to go 1 unit and then 1 unit. So your answers are definitely okay. But then here you see they want the coordinates. So you cannot just leave answers like this. Here you have to say, therefore, P, as we can see, it's on the left side. So the x value is negative 3, but the y value is 0. So negative 3 here, give us 0 there. Q, same idea, positive 1 and 0. Ooh. Let us add our comrade once again. Gigs. Stop video, just wait. Is the same person? I don't know. Anyways, for 2 marks here, right, they said we should determine the equation of the inverse of G in the form Y. So getting the inverse of G, not a hassle at all. Here is just a half to the power of x, right? That's the original equation. So if your original equation has a half to the power of x, remember inverse just means that you swap around x and y, you see. So let's just say it like this. G of x becomes x, x becomes, no, let's just make it simple, you know. Y becomes x, x becomes y. So that being said, here we can easily put an x there, and this we can make it to the power of y. And then, because we're trying to get the inverse, remember, we're trying to isolate the exponent. Anytime you're trying to isolate the exponent, you have to use logs, see. So in terms of isolating the exponent, you isolate it, you make it on its own, and then the base of the exponent, you make that this value there for your log. And then whatever this x is, it's just gonna still be there. You see, now that's your answer. You can maybe write the y first. See, y is equal to log the half over here, the x over there. And then you're gonna get your 2 marks. You're gonna get 2 nice marks there. And yeah, that is that. 5.5 is a 3-mark question. This 3-mark question says we should sketch the graph of the inverse, right? So sketching the graph of the inverse, it's not going to be difficult at all. The reason why sketching the graph of the inverse is not going to be difficult is because as long as you have the original picture, your life will always be good. Because if we just draw this original picture on our sketch, drawing the inverse will be easy. You see, so this is the original picture. I'm just drawing the original picture so that drawing the inverse is a bit easier for us. You see, so this is what the original picture looks like. Now, for you to draw the inverse, right, all you need is the line of inverse. Remember, the line of inverse is the line y is equal to x, and it's this line over here. So as long as you have this line y is equal to x, which you should draw it out when you draw the inverse of the graph, as long as you have this line of inverse, drawing the inverse of your original graph should not be a hassle, because all you do is you have to remember that your inverse is a reflection about this line, meaning all you want to do is, what I normally do is just, for example, look at where this is, right? So if this is here, if you're going to reflect it about this line, right? So whatever this distance is, it should be the same going that way. So you should have your arrow somewhere there. And then for this arrow here, you can see if you go directly to your line of inverse, you see, whatever this distance is to the line of inverse, it should be the other way, going like that, you see. So you know your other arrow is there. Because you see here, these should be mirror images of each other. And then this should be mirroring there. So now your graphs should also always meet each other on the line of inverse. So with all this information, you can easily draw your curve. See, oh, that was going so well until my fingers started doing things. But let's see. Let's move that, do it a bit better. There we go. Let me put a nicer arrow here, and then we'll have our images. So that's what you can do whenever you need to draw the inverse. Just make use of your line of inverse, you see, because remember the idea is this distance here is the same there, and then this distance here is the same there, you see. So as long as you can remember that, you're good to go. These, you can see it's a mirror image of each other. Same here. So they should just be mirroring each other. And then this, remember, we don't need it, the original one. We just drew it so that it can help us draw the inverse, you see. So it's something you can always do for yourself. And then we can just label the inverse, you see, g negative 1 x. And then you'll get yourself 3 good marks. Label the x-axis, label the y-axis. And then, yeah, life is good, LG. So with 5.6, it's a 2-mark question. They said for which values of x is the inverse of g bigger or equal to negative 2. So a question like this needs you to make use of the equation of your graph and the picture. Well, you don't necessarily need the picture, but the picture will help you, because this is just asking you where are the y values of the inverse bigger or equal to negative 2. So firstly, you can just think to yourself, where would the y value negative 2 be? So negative 2 would be somewhere over here, you see, just an estimate. So if your y value of negative 2 is like somewhere here, this is where your y value would be negative 2, right? So if we look at the question again, this is asking for which values of x is the y value below negative 2. So what we can see is, if you're going to work out where the y value is below negative 2, what you can see from your picture is that this portion here is the part that is below negative 2. So this part that is below negative 2, it's going to be x values starting over here, going to positive infinity. The x values starting from here, those are the x values that are going to be producing these y values that are below 2. So what we need to do is to find out the x value here. And then as an answer here, we'll be able to say the x values need to be bigger than whatever this x value is. So finding this x value, it's not a problem at all, because if you're going to find out where something is, oh, no, I'm mixing it up. This is asking where is it above negative 2. Yeah, let me change my words. They're asking us where are the y values above -2. So they're above -2 here. This is the part where the y values are above -2. So here the question is asking for which x values are the y values above or equal to -2. So that's happening between 0 and whatever this x value is. Because clearly between this x value and 0 here, that's the portion where your y values are bigger than -2. So for us to answer our question, we have to find out what is this x value first. Now to find out this x value, we just have to throw -2 into our equation of our inverse. And we have the equation of our inverse, you see. Let's see here, y, let's go to log, half here, and here we have x. So we need to find out where the y value is -2. So we're gonna put -2 over here. Solving for x here, it's not difficult at all because remember, in this format, we know that this is an exponent, this is a base. So you're gonna have your base as a half, exponent as -2, and then x on its own, you see. And then here, this is something you can put in your calculator, you see. A half to the power of -2 is going to give you a 4. It's gonna give us 4. Is it gonna give us a 4? Yes. So this x value here is a 4. What that means is the x value here is a 4. This is just a 0. So we know that the y values are above -2 from 0 until 4, because as long as you're considering x values between 0 and 4, those x values are going to be producing these y values over here. See, so let's give that as an answer. So here we can say x is between, let's just say here, x is the element of 0 until 4. Here we have to put a square bracket at 4, because specifically at 4, the graph is equal to -2, which is what this question also says. You see, the question wants us to get where is it above 2, or where is it equal to where is it above -2, or where is it equal to 2? So that's how we answer this question. We have to put the square bracket for the 4. The reason we're putting the round bracket for the 0 is because specifically at 0, the graph will never touch 0, you see. So we're saying between 0 and 4, where 0 is not included, the 4 is included. Now, the way we have answered this question, right, we didn't make use of our sketch very much, but we looked at it. The next question, though, is definitely going to need us to make use of our sketch, because these kinds of questions, right, you don't necessarily work them out algebraically. You actually work them out using a diagram. So in our diagram here, right, what they're asking us is, where will this expression be a number that is smaller than 0? That's the question that is being asked here, you see. So with a question like this one, right, you need to be careful, because a question like this is basically asking you, two things are being multiplied together. What will result? What values will make this left side a negative? Now, the one way to always work questions like this is to think to yourself, there's one thing over here, and then there is another thing over here, you see. So two things are being multiplied together. The only way you'll have a negative value coming out is if one of them is a plus while the other one is a minus, or if this one is the minus while this one is a plus. You see, it's all a matter of determining, okay, where will this one be a positive number while this one is a negative number? Where will this one be a negative number while this one is a positive number? Because as long as that's happening, this will always be a negative, this will always be a negative. Now, with questions like these, right, for you to answer them properly, you also definitely need the sketch. Because let me actually have the sketch somewhere down there, so that we don't keep scrolling up and down. Because as long as the sketch is like directly next to us, a question like this will be much easier to understand and much easier to explain, you see, because pictures make the world go around. As long as you have a picture, yeah, life is good, you see. So if you looking at our picture here, right, let me just clean it up a bit because we don't need all this other information for now. Do this, this, do this, do this. So with our picture here, this is actually our picture of, is this our inverse? Yes, that's our inverse. Wait a minute. We're talking about f of x, not g of x. Well, that makes life a bit different. Let's just delete this image because this is the graph of g. I'm not realizing now that, wait, that's the graph of g. We're talking about the graph of f. I guess it kind of makes sense that we're talking about the graph of f because we really haven't made use of f. Does somebody want to say something or not? I think I heard something. Oh well, I guess it's sorted. So anyways, we have this parabola here, and that's the graph we're basically working with. Yeah, the sketch here, it doesn't look very pretty. It actually looks terrible. Let me actually try and do it better. Hello, did someone forget their mic on? Or not? Anyway, so with this next question, we need to make use of the graph of f of x. So this question is literally asking us, where will this expression be giving us negative values? So the only way you're going to get a negative value here is if you have negative x values while having positive y values. Because remember, this is representing y values of f. This is representing y values of f. This is representing x values. So technically speaking, this is saying your x values multiplied by your y values. Where will this be a negative number? So all we need to do here is we can actually use colors to help us. Let's color code this image. Here I'm coloring out where you have positive y values. This is where you have positive y values. This is where you have positive y values. And then let's just add our comrade here. Admit. So here, this is where you have positive y values. This is where you have positive y values. And then obviously below that, this is where you have negative y values. Here you also have negative y values. Now, obviously, if you look nicely, this part here, you have positive x values. And then to the left, you have negative x values, you see. So the red is representing positive y values and positive x values. The yellow is representing positive x values. Is representing negative x values and negative y values. So when it is color coded like this, it kind of makes our life a bit easier. Let me actually do something better by making this a bit thicker. So this is positive y values, positive y values. And then going to the right, this is positive x values, you see. Now the yellow is representing negative x values and negative y values. I think this is much better to look at. So when you have a picture like this, answering your question here becomes a little bit easier because all we have to do now is we need to look for portions of our sketch, right? Where we, for example, have positive x values while having negative y values, you see. So let's do that. So here we can see positive x values are here. So we want where we have positive x values together with negative y values. And that's only happening between here until there, you see. This x value, we know it's a positive 1. This x value, we know it's a 0, you see. So what we can see is between 0 and 1, that's a portion where you have positive x values together with negative y values, you see, which is a portion that's going to definitely give us a value that's a negative value here. Because if you put a positive x value here and a negative y value, these two multiplied together, will give you a value smaller than 0. So the first portion of our answer, we're going to say x is an element of 0 until positive 1. The 0 and the 1, they are not included because specifically at 1, you have a y value of 0 there. Specifically at 0, you have an x value of 0. So if any of these is a 0, if you multiply them, you just get a 0. And 0 is not smaller than 0. This is the first portion of your answer. So we want here also, you see, we want where you have negative x values together with positive y values. And that is happening from here, going all the way to negative infinity. From here, going all the way to negative infinity, we can see that you are going to be having positive y values here while having negative x values, you see. So that portion definitely qualifies for our answer. So we're going to say here, x element of negative infinity until until negative 3. That value, we got it to be a negative 3. Let me just draw this a bit better. Negative infinity until negative 3. So again, infinity will always be not included. Specifically at negative 3, you have a y value of 0 there. So 0 times anything will be a 0. So if any of these is a 0, you cannot get a value smaller than 0. That's why we have to not include the negative 3 there. So for this question, right, for 3 marks, that's what we're going to have to say. These are our two answers, you see, because it's just asking where the x values times the y values giving a number smaller than 0. And here, as long as you have color coded it, you can easily answer your question, because all we're looking out for here is a portion where you have red and yellow together, and then another side, a portion where you also have the red and the yellow happening at the same x values, you see. It says the following. For how long must 50,000 be invested so that it can double? And then it says here, how long must 50,000 be invested so that it can double at an interest rate of 8.5% per annum? And then it says here on a straight line balance. On a straight line method. So straight line method, this is something quite interesting. This refers to simple compound interest, actually. No, that's like a weird way of saying it. It's just simple interest, because when I say compound, that's wrong. We're just going to have to use the simple interest formula here, meaning we have to use A is equal to P 1 plus I multiplied by N. So here, they want us to find out how long. So we have to work out N. So if you're going to work out N, you can either isolate N right now or put in numbers and then isolate N. I usually prefer isolating the variable first, especially if it's like a weird variable like N, So let's see what happens if you want to make N the subject of the formula. So the first thing is you would divide both sides by P, because remember, we're trying to make N the subject of the formula. So you would divide both sides by P. The P here would cancel this P. So you have A here over P, right? Equal to 1 plus I times N. The N and the I, remember, they're being pasted together. So with this being said, the 1 can move to the left. You're going to have here A over P minus 1. This whole thing is equal to I times N. Okay, let us add our comrade issue, because why not, right? Because why not? And then now remember, everything on the left is together. With financial maths, it's always better to actually isolate a variable before you throw in numbers, because you don't want to find yourself, putting answers in your calculator, having these long decimals, and then getting tempted to round off, or you do round off, and then now you end up losing a mark because of that. But here, since we're working out N, we can divide both sides by I. So divide by I here, divide by I here. And you don't want to find yourself panicking because you have like a fraction over a fraction. Nope. You just want to get used to it, because remember, your calculator does all that work for you anyways. It's just a matter of pressing the fraction button once, putting brackets, pressing the fraction button again, putting numbers, and then minus 1. You don't want to find yourself getting a bit disturbed by that. You don't want to get disturbed by that, because there's really no reason to be disturbed by things like this. But anyway, so our question wants us to find out how long 50,000 needs to be invested for it to double. Meaning the amount when the investment is made is 50,000, but then the amount after the period of investment should be 100,000, you know, because they're saying how long does it take for the amount to be doubled. So P has to be 50,000, A has to be 100,000. The interest rate, they said it's 8% per annum, right? So our interest is just 8.5%. Interest is just 8.5%. Our value of N is what we're looking for. And then because they said on a straight line method, we have to use the simple interest formula. And here, as we can see, we just isolated N since we're looking for the time period. You see how long. So we said here A, right, has to be 100,000. Like a bit better. 100 and then 1, 2, 3. P is like 50 and then 1, 2, 3. And then the whole thing here over 8.5%. Remember, the percentage symbol, you do have to put it in your calculator if you want to use the number 8.5. But if you want to use 0.085, that is 100% A-OK. So let's put this in the calculator. Remember, we said the first thing we just have to do is to press the fraction button. And then at the top, we're going to put brackets. Inside the brackets, we're going to press the fraction button again. We're going to put 100,000 over 50,000. Next to it, we're going to put -1. Below it, we're going to put 8.5 shift percent. And then this is like 200 over 17. So yeah, N is equal to 200 over 17, which is kind of weird, you know, but we obviously want to see what this value would be in like months or years and all that. So because this is per annum, you have to remember that if it's per annum, right, it means that the value of N that we have is going to be years. So here, this is like 11.75. No, let's say 11.76 years. 76 years. But the one thing is, if you ever want to convert your years to something that you can write as years and months, all you do is remember this 0.067. I mean, this 0.76, right? You can just convert it to months by saying 0.76 times by 12 gives you how many months this represents. So let's see what that gives us in the calculator. 0.76 times 12, that's going to give us 9, you know? So let me actually do this. Oh, I'm going to put the approximate symbol. Zoop. Do this, do this. So this is approximately 9 months. So here we can say, therefore, 11 years, 11 years, and 9 months. If you wrote it like this, that's still 100% fine because here they didn't necessarily specify. Oh, they did. What a wow. I think my subconscious probably saw this. Maybe not. Maybe it's just a habit for me. So they say give your answer in years and months, right? So the years we have given them 11, and then the months we said just take this value there, the 0.76, and then you have to multiply that by total wealth for 12 months. That's 6.1, right? 6.2, it says a cell phone is valued at 24,000. Yes, probably an iPhone 13 Pro Max. And then it says it depreciates at 18% per annum on the reducing balance method. So reducing balance method, that's like you can almost say negative compound interest, you know. Then it says here, determine the value of the cell phone after 3 years. So it's not bad at all. The money when the time period starts, or the value when the time period starts. Remember, that's your value of P. And then your interest, they said it's 18% per annum. So we don't have to do anything to the 18. It's not divided by anything. And then here, after 3 years. So remember, because this is per annum, the 3 is just 3. If it was per annum, I mean, if it was 18% per annum compounded monthly, then we would times this by 12, would divide this by 12. But because there's nothing like that here, we don't have to do any of that. Hence why this is also just a 3-mark question. So this all being said, let's put all this into the calculator. 24,000. Then we have 1 minus 18 shift percent, the whole thing to the power of 3 This is giving us 13,232.832, right? That's your value of A. And that's not bad. It's not bad at all. For 3 years, phone. Most phones would be worth nothing. But he's okay. He's okay. Let's see what we can do in the last question here. The last question. Wait a minute. I did this question. Did I? No. No, I probably didn't. I probably did though. No. It just looks similar to this financial math question that I did like a day or two ago. But it says X rands is invested into an account, right? At an interest rate of 12% per annum compounded monthly. Then it says 3 years later, 2 times that amount is deposited into the same account after 7. And then it says, after 7 years, there is 276,558.75 in the account. Determine how much money was invested in the beginning. It says here, that is the value of X. So we just need to solve for X for 6 marks. Honestly speaking, this question, in as much as it may seem like it's going to be hectic, it's actually not going to be hectic, this kind of a question, because they've done us a favor by giving us the idea that whatever we're going to do, right? I mean, like there's one variable, which is X. With questions like these, you just want to draw out a timeline of some sort. And in a timeline, every time there's like some kind of a change, let's say they add money, they remove money, interest rate changes, anytime something like that happens, that's the time when you need to perform like an extra calculation in addition to whatever you would have already calculated. So for example, right, in the beginning, they said money is invested. So in the beginning here, you add money. You don't know how much it is. But then that money is invested into an account with this specific interest rate. So the interest rate in this time period is 12% per annum compounded monthly. So it's 12% compounded monthly. And then it says 3 years later. So you see here, something is about to happen. So that's why we have to, here it means we have to perform a calculation. So from here all the way until here, right, the interest rate is 12% per annum. Money was added here, and then money is about to be added again. So obviously, whenever money is about to be added again, you need to keep track of how much is in the account to begin with. Because for you to add money into, for you to do something to your calculation, right, you have to keep track of what you currently are working with. So for example, when X is invested over the 3-year period, before you can add this money, you want to work out how much is in the account after those 3 years, and then you add this money, you see. So that's the idea behind like keeping track of how much is in the account. You always want to work out what is in the account before you like add something to it, or before you subtract something from it. So then here they say 3 years later, 2x rands is deposited into the same account. And then you see here, they didn't say anything about the interest rate changing. So you see here, the interest rate is still the same, 12% per annum compounded monthly. Now they said after 7 years, there is this much in the account. So we know that here 7 years have passed. And then in these 7 years, right, there is this much in the account. So here in the account, you have 276,558.75 in the account. Then they said determine how much money was invested at the beginning. So to do that, you don't even have to work backwards here. You can just work forward and then eventually solve for X. So working forward, the fortunate thing is there are no monthly installments here. It's just money being put in and then it sits. So in that situation, you should remember that you just need to use the compound interest formula. A is equal to P 1 plus I to the power of N. Now we said every time like something changes, let's say they have to add money or remove money or whatever, you have to perform a calculation. So between this beginning and this 3-year period, we have to perform a calculation here, right? Meaning, remember, in the beginning, money was added into the account. So that represents P, money put in. And then that money, the interest rate, 12% per annum compounded monthly, it's set there for 3 years. So that's like 3 times 12, right? Now we know that at the end of the 3 years, this figure here, we don't have an actual number, but then whether we like it or not. This here is telling us what is in the account after those 3 years. So what you are better off doing is, let's see what this value is, right? It's X here. Let's see what this number is in the calculator. It's going to be like a long number, maybe like 0. Whatever, it doesn't matter. But we need this value here, because you see this is like in brackets to the power of 36, which is what 3.12 is. So let's find out what that figure is, because it's going to give us a better idea of how much is in the account after that 3-year period. So let's see here, 1 plus 12 shift percent over 12, the whole thing to the power of 36. This is giving us 1 point, yeah, so you see this number here, 1 point whatever. We have to write down the whole thing, like literally the whole thing. 1.43076874, like that. So that's how much is in the account after 3 years. So to this value, to this money, right, they added, let me remove A here. To this money, right, they added 2x to it. You see, so they added 2x to it, and then after adding 2x to it, they left it for 7 years at this interest rate. So if you think of the compound interest formula, right, when during this 7-year period, this is the money you let's say put into the account. So it's this value here plus 2x. Let's see what that is. Remember, 2x plus this value x would just give you 3.1, no, 3.4307687884x, you see. Remember here I just wrote x in front, but you know it's the same thing. It's just like this value x plus 2x. So it's just like this number plus 2. It's just like saying 1x plus 2x. 1x plus 2x would give you 3x. But then because this has a decimal, I mean the decimal will still be there. So this is actually what's in the account after the 3 years, right? This being what's in the account after the 3 years. What we know is this money here, right? We are going to put it again into the compound interest formula. It's going to be a value of 4p here. And then our interest rate is still just 12% per annum compounded monthly. But then this money is going to sit for 7 years now. You see, 7 years compounded monthly, that's 7 times 12. But then what they've told us about this money sitting for 7 years is that when it sits for these 7 years, right, it is going to accumulate to 276,558.75. So what we know is this is equal to 276,558.75. That's what we know during this 7-year period. It's going to sit there. It's going to add up to this. So if you're going to solve for x, obviously your best bet is to isolate x. Obviously, isolating x, you want to get a value for this bracket to the power of 7 times 12. So that's not going to be difficult. We just want to be careful. So let's see what that gives us. This here, let's see, it's still going to be 3.43076878 right? So these kinds of questions, don't be intimidated by how you're just going to be writing a lot of decimals. And writing a lot of decimals should not make you think that what you're doing is wrong. Because sometimes a question looks weird when the numbers are just like long decimals and all that. You know, it's easy for a person to think, is this even correct? But as you're seeing, if it's like that, yes, it's definitely still correct, you know? So this whole number here would give you, let me actually color code this nicely. I don't even know why I'm changing the colors here. Like, come on, it was working so nicely. Let me change this. Let me just keep this pink. Man, come on. Pink, change style, pink. Perfect. So this value here, let's see, it's in the calculator. It is giving us 2.3067227 and then this is like 276,558.75. Perfect. Now remember, this value is being multiplied by this value. So you can actually just put those numbers in your calculator. This number here, you can just times it by the 2 point whatever. So here times the 3.43076878 that is giving us 7.913832384x, right? This is equal to our 276,558.75. Perfect. Now, all this being done, right? All this being done. Let's divide this by 7.9138323884. Then also this side 7.9138323884. And then let's see what this gives us. This cancels this. This is giving us a value of x, right? Let's see what that is giving us. 276,558.75 divided by 7.9138323323, right, and then 84. Great. So our value of x here is 34,946.25. Question 7 here, first principles question. The one thing I always do with first principles questions is you always want to try and differentiate this using the short method so that you see what answer you're working towards, you see. So differentiating this, you're going to have here f of x, and then you're going to have the negative 4x as your derivative, you see. And then here plus 1, because remember, when you differentiate this, it's going to be 1 times 1, which is a 1, and then the 1 minus the 1 gives you x to the power of 0, which is fine, you see. So here, this is what we should be working towards. So when you start, we know you have your formula, right? F prime is equal to lim h goes to 0. Let's do here lim h goes to 0. This is like fx plus h minus f of x. Is this a plus or a minus? This is one of those things where I'm like, hey, the formula sheet needs to come to the rescue, because I know it's a plus, but at the same time I'm just like, let me just double check, because why not? Why not? The formula sheet is free. It's there to use whenever you want it. So when something is like not clicking in your head, right? The least you can do is to just double check on the formula sheet. And yep, it's actually a plus. So I guess we're on the right track. So what I always do is, before you put stuff into your formula, right, always try and work out what this is. You see the fx plus h. So on your answer sheet, you can put fx plus h there. All that means is, in the equation of your original function, right, wherever x is, you plus h. So let's do that. Negative 2 x plus h squared plus x plus h. Now here, you can have here negative 2 outside, right? So x times x is x squared plus 2xh plus h squared, and then here plus x plus h. Now, obviously, you're going to have to multiply the negative 2 inside. You can have negative 2x squared minus 4. See here, I was about to make a grand mistake. Minus 4xh, then minus 2h squared plus x plus h. Simplifying this, you cannot simplify any further. But at least you would have done all this separately from your big question, you see. So now you can just carry on in your equation of f of x. You can just say here in the equation of f prime, we have your lim h goes to 0. And then what we now know is this fx plus h, right, is just going to be equal to this entire statement here. So you can put the negative 2x squared minus 4xh minus 2h squared plus x plus h. And then here you're going to see, you're going to minus this equation. So as long as you're minusing this equation, right, it means that this sign is going to change, this sign is going to change, you see. So here you're going to have plus 2x squared, and then you're going to have minus x over there, you see. And then at the bottom, you just have your h. So the one way you can always remember that the signs of these two changes, the one way you can always remember is by the following step. You see, every time you have thrown in everything into your formula, this entire equation should be cancelled by values in your formula, you see, because this is a negative 2x squared and plus 2x squared. This is positive x, negative x, so those should cancel out. And then here the lim h goes to 0, you should just skip that. And then here we have negative 4xh minus 2h squared, the whole thing over h. Fortunately here, something is not looking good. Maybe because I'm focusing on this and I'm seeing how this is now, and I'm like, where is the answer gonna come from now? It's looking. Let me see if I made a mistake. I probably did. Let's see. H. This is fine. This is fine. This is fine. And then there's X there. H there. Oh yeah, there we go. I forgot this here. The plus H. Yeah, that makes sense because I knew something was off. But either way though. Okay, let's just carry on and see where this ends up. So here we can see there's a H everywhere. So we can just take out H as a common factor. So if H goes out as a common factor, we have negative 4x here. And then minus 2h. And then here plus 1. Oh, okay, that's good. Because that's where this plus 1 is going to come from, you see. So you can see why it's important to like try and work out your question before you do anything. Because you see here, I'd already forgotten this. Not necessarily forgotten it, I didn't see it. It's like there, but for some odd reason, I didn't write it out. But it's okay. So here, this cancels that. Now, as long as you have your h gone at the bottom there, this whole h tends to 0 takes effect now. Because all that means is where the h is, a 0 is just going to be dropped over there. And then as long as a 0 is dropped over there, you're going to have 4x. You're going to have negative 4x plus the 1 left. You see, that's why you don't now have to put the whole lim h goes to 0 thing. But you have to keep it there so that the moment you drop it, it means that you have just subbed in a 0 where h is. You see. And then you'll get all your 5 marks over there. So that's an okay question. These are the kinds of questions you should never, because they are the same all the time, you see. Same idea. So for these 3 marks, you want to make sure that you simplify your expression until each term has a coefficient, a base, and an exponent. As long as you have this, you can always now differentiate it because it's going to be exponent times the base, and then removing 1 from the exponent. So with that being said, let's differentiate this equation. So differentiating this equation, we have to simplify first until we have to make sure everything has this format. So this first term here, right? What we can do first is, you see the bottom part here, you have to remember that as long as there's nothing here, there's like a 2 there and a 1 there. So the first thing you can do is to try and have this as a base and an exponent only, so that you can simplify. So doing that, the negative 5x is still there. Here you have x to the power of a half. Now here, this 5, you want to remember that there's technically a 1 here, right? So what you're seeing here is technically minus 1 over 5 with x squared there. You see, that's what you should be seeing, because it makes your life easier when you have to differentiate, you see. So when you're also simplifying, don't be in a hurry, because there's no point, just simplify nicely. For example, now here you can easily see that, okay, there's a base here to an exponent, there's a base here to the power of an exponent. The bases here are the same and you are dividing, so you can subtract the exponents, you see. So this simplified, your -5 is going to be there. And then here you're going to have 1 minus a half. So 1 minus a half is a half. Because remember, your bases are the same, so you're minusing the exponents. And then here you still have your -1/5 x squared. So as long as you're simplifying, you have to keep the dx here. You have to keep the square brackets over there. Now, so that the moment you differentiate, you can just put an equal to sign and then differentiate, you see. A half times -5, maybe -5/2. A half minus 1 is minus a half. Here, 2 times -1/5 is going to give you -2/5. Removing 1 from the exponent is just a 1, and then this is what you have. So because this is a differentiated equation, it's your final answer. That's why you're just leaving it like all this. Okay. So it says the following, question 8. The sketch below represents the functions f of x is equal to this. So the one thing that stands out with a question like this one is that already here you can see that the value of a is given. You see, as long as there's no number directly in front here, the number there is a 1. Yeah, the number there is a 1. So since this number here is a 1, it says here the sketch below represents functions and g of x is equal to this. And then it says the points A, B, and C are points where the two graphs intersect. Okay, it's the points where the two graphs intersect. Let me see here, A, B, and C. There's A here, B here, C here. Okay, fantastic. Let's see. Those are the points where the graphs meet. And then it says here, the points A, B, and C are points where the two graphs intersect. Okay, fine. And then it says here, C is the x-intercept of F, while M, L, and M, these are the turning points. So there's a turning point over here, and then there is a turning point over there. Okay, so this doesn't look bad at all, because we just have to clear an open, we just have to keep it open, an open mind. It says show that B and C are equal to these values, and then D is equal to 12, given that the first derivative is this. So you see, the reason why they're giving you the first derivative is because they want you to what is this? To make use of it. You see, they won't give you anything just for the sake of giving it. You know, they'll definitely only give you something so that you make use of it. So you can see here, the first derivative is useful because if you see what f of x is originally equal to this, x cubed plus dx squared, and then here plus cx plus d, right? Plus cx plus d. Yeah, so they've given this, so they've given you this equation, right? And obviously its first derivative, we know that this is where we could start. Differentiating this is going to allow us to make use of this side. So this differentiated is equal to 3x squared, and then we have plus 2bx, and then plus c. You see, that's the first derivative. Now, automatically, you can see here, what we have here, right, is we have to mix and match. Technically speaking, the 3 here goes with the 3 there, fine. The -10 goes with the 2b, you see. So automatically -10 is equal to 2b. And then we can work out b here. Divide both sides by 2, you have -5. For the 8, it goes with the c, you see. C is equal to -8. So you have b, you have c. Now d is automatically just the x-intercept. I mean the y-intercept, sorry. The y-intercept of our graph. Now, fortunately, we have a point that the graph passes through here. This is a point that the graph passes through. So you can imagine in this equation, we have b now, we have c now, and we can just throw in a coordinate that the graph passes through. You can just throw in a coordinate that the graph passes through, which is a y value and a x value. So if you throw in an x value and a y value, we will have an equation where we can easily just work out the value of d, you see. Is that fine?
Yes.
Okay. So let's see here. What's the thing here? Yeah, so carrying on from here, right? We know that we have to now make use of the information we have gotten to get a value of d. So meaning in the main equation, right? F of x, let's see here, f of x, and write this out. F of x is equal to, what's that thing here? F of x is equal to, I'm just trying to see this nicely, x squared, x cubed, and then we said our value of b is minus 5, right? So we're going to have minus 5x squared over there, minus 5x squared. And then we're going to have here, what's the value of c? We're going to have the negative 8x, negative 8x, and then our value of d there is going to be just d, since we're trying to work it out. So we're going to put plus d. So seeing it like this, right, what we're trying to say is, okay, fine, let's just throw in a coordinate that the graph passes through, 2 and negative 16. So here, this is like negative 16, and then we have 2 here, and then 2 over there, 2 over there. And then let's see, 2 cubed is a 8, 2 squared is a 4, so that's like 4 times that, that's like a 20, 16, and then what do we have now? So if you move everything on one side, right, it's going to be negative 16 minus 8 plus 20 plus 16 equals to d. And then here, this is going to cancel this. And then what now? Negative 8 plus, 20 minus 8 is like a 12.
12.
Yeah. Yes, it is. So you see, now we have found out that d is a 12. So everything links up, you see. 12, negative 8, and then negative 5. So here you can say therefore. You don't even have to say therefore, because like everything was worked out properly. There's B, there's C, and there's D over there. So 8.2 says we should do what? 8.2 says we should determine the coordinates of the turning points, which is L and M or F, right? So with that being said, if you're going to determine the coordinates of L and M, L and M is basically the what is this? Those are just the turning points. You see, those are just the turning points. So if we're going to get the turning points of our graph, we already have the equation anyways. So this question, whether or not a person got the first one right, it doesn't matter, you see, because getting the turning points, you can just make use of the equation. So it says you determine the coordinates of the turning points, L and M, of F, right? So getting the turning points, let's make use of the equation that we now have. Fortunately, we can actually just make use of the first derivative, because that's actually what we need to get the turning point. Because remember, to get the turning point, what we know is that at a turning point, the derivative there, the gradient is a 0. The gradient here also is a 0, you see. So the idea is, all we will be doing is, our second derivative is our gradient equation of our graph. So in this gradient equation of our graph, all we will be saying is that we are looking for the x value where the gradient is a 0, you see. So carrying on from here, let's just solve for x. We can just use the quadratic formula. X is equal to minus b plus minus b squared minus 4ac over 2a. Let's see here. Let's see. B is like negative 10 plus minus like negative 10 squared minus 4. Our a value is a 3. C value is a negative 8. And then our a value is like a 3 there. And then what now? So this is like, let's just put all this in the calculator. Let's see here.
The first answer is 4.
Thank you, ma'am. Thank you so much. Thank you so much. The other one?
It's -2/3.
-2/3. -2/3. -2/3. Yeah, so in the equation, let me just copy the equation here. Get this whole thing. And then our d value, we got it as a 12. We'll put a 12 here. So the first, so for the first x value, what's the answer?
It's 4. It's 4.
4. Again. 4.
The first x was 4, then the second one was
Oh no, I mean,
-2.
what's the first? What's the first answer for the 4? If we put into the equation.
Oh, sorry. Let me substitute it.
Yeah. Okay, so for the you say which one is for -36?
The 4.
Okay, thank you so much. Let me see here, -36, and then the other one, the one for the -2/3.
It's 2/3. 2/3. It's 14,81.
14,81. Okay, let me just write this out. 14.81. Okay, so since it's a fraction here, I mean, like, you may want to actually have this as a fraction also. What's the fraction value?
It's 14,81.
No, the fraction.
Oh, sorry, it's 400/27. Sorry.
400/27.
Yes.
Yeah, so this is actually the better option, because normally if this is a fraction, you want to have this as a fraction also.
Okay.
Anyway, so it looks like our turning points, if you look nicely, right, let's see if this is kind of like matching up. Yeah, if this is -16, -32 down there is reasonable. Yeah, let's see here. Let's see. Okay, the next one here is 8.3. Determine the equation of G. So G, it's just the equation of the straight line.
Okay.
Yeah, so getting the equation of the straight line is quite straightforward. Fortunately, because we have two coordinates that we can use to work out A and Q. We can use this to work out A and Q properly. So getting a value of A and Q, we can just use this coordinate here, 6 coordinate 0. Because remember, usually if you're going to get two coordinates, you can just, if you're going to get two variables, you can work them out simultaneously. So the equation of G, it says here, G of X is equal to what is the thing? AX plus Q. AX plus Q. AX plus Q, right? So the first coordinate is 2 and -16. 2 and.
So is it okay if I use the second derivative?
Well, the second derivative is really not going to get much from this straight line, because remember, the big idea is whatever you need to get, if you're going to think of doing something, ask yourself why. You see, so for example, if you're going to think, okay, let me use the first derivative, the question would be, but why? The second, well, if you use the second derivative is just going to leave you with A, because if you differentiate once, you have, well, the second derivative is not going to get you anything actually, because the first one leaves you with A, right? But then when you differentiate again, this is a constant. So you see, differentiating a constant, it just comes at it as a 0. So you can see the differentiating idea is not necessarily going to help us. But then as we said, right, we have two coordinates, you see, #1, #2. That can help us to get A and Q simultaneously. Does that make sense?
Yes.
Fantastic, 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 fantastic. Anyways, so let's move on then. Let us move on to the next thing. The next thing that we said we're gonna do, what did we say we're gonna do? We're gonna have here, where's g of x? There's g of x here, a of x over there. So here we can say x1, y1, x2, y2. So let's see here. We can put the g of x side, we can put the negative 16. And then the x value here, we can put it 2. And then get an equation. We can actually make q the subject of the formula here. This is going to be negative 16 plus 2a. Let me just step this out here. Move this to the left. Negative 16 minus 2a equal to 2. So we can label this equation number 1, right? Equation number 2, we will have these coordinates, y as a 0, and then a as, the x value is 6. So times 6 over there. And then, again, here we can actually take the negative 6a to the other side. And then label this equation number 2. So they're both equal to q, right? So we can actually just make them equal to each other, you see. Equation number 1 equal to equation number 2. We're going to have negative 16 minus 2a equal to negative 6a, like that. Does that make sense? Yeah. So, all this being said, let's take, there's going to be negative 2a here. Move this over, that's like plus 6a. Move this over, that's like positive 16. Negative 2 plus 6, that's like a 4. Divide both sides by 4. That's like a. And then 4. So a is a 4. And then here, therefore, 6a, or rather 6 times 4 is equal to q. Negative 6 times 4 is equal to q, which is going to give us negative 24. And that's the way we like it. So here we can then give the equation of our straight line. So, oof, I ran out of space here. Like, come on, bro, come on. Let's move this a bit higher. So here we can say, therefore, g of x is equal to 4x minus 24. And that is the way we like it. Does that make sense?
Yep. I'm just sad but I got the answer wrong because I used the second derivative.
Nice. It's okay. Let's do the next question then. Let's see, what's the next thing now? The next thing. Oh yeah, it says it is further given that the coordinates. Let's see.
The distance.
What is the question? Do you mind reading the question?
Yes. If it is further given that the coordinates of A are x is to negative 36, determine the length of AM.
Okay. So, yeah. So with this question, right? It says it's clearly one of those questions where it says if it is further given that the coordinates of point A are that determine the length of AM. Where is AM? AM is, well, there's A over here. There's M over there. So if you're going to get the length of AM, that's not a difficult question, right? Even if you check the, the mark allocation, it's just a 3-mark question. So in this 3-mark question, they've given us the y value of a, right? Remember we had the y value of m. What is the y value of m again? It was, I think, negative 36. So you see, this makes our life so much easier because automatically, as long as a and m have the same y value, what we now know is that this is a straight line from a to m. It's like a proper straight line because remember this was like a 4, negative 36. So to get the distance between a and m, all we need is the x value of a. Because as long as we have the x value, we can just compare the distance between the x values. And fortunately, do you see that a is a point where the straight line passes through? Yeah, so that's our bingo right there. Because in the equation of our straight line, we can just put 36 as the coordinate for the y value, and then we can just get the x value. So here 24, we have this to the other side, 36 plus 24, and this is like 4x, right? So negative 36 plus 24, negative 36 plus 24, that's like negative 12. Yes. Negative 12, 4x. Divide both sides by 4, divide by 4, divide by 4. What do we have here? Negative 12 divided by 4.
3.
Negative 12 divided by 4 is going to give you negative 3 actually. Yeah, negative 3. Which makes sense because that x value is on the left side, you see. So if this is like 3 units from the y-axis and then 4 units from the y-axis, the total distance is going to be a 7, you see. Because you see from here to there, this is like 4. And then from here to there, that's like 3. You see, because remember when it comes to distance, you always take the number of units from the origin. So here, therefore, AM is equal to 3 plus 4, which is 7 units. 7 Dylan. 7 Dylan. Oh, so what am I saying? Let me see here. What am I saying? Yeah, it's the number is 7. I don't even know what's going in my head, to be honest. But hey, yeah, nah. Let's see here. Anyways, it's fine. So with the next question, right? It's 8.5. 8.5. 8.5 says, for which values of x is the graph increasing? So with questions like these, they're quite straightforward, you see. I think that's why you will note questions like these on the main channel. They were like 2 minutes long, I think 3 minutes long, something like that. Because the way you answer these questions, right, it's quite straightforward. You literally have to focus on something specific on the sketch. As long as you can focus on the correct portion of the sketch, you can easily always answer these kinds of questions like 100% of the time. For example, a graph, in terms of where it's increasing or decreasing, it's all about the y values, how they are behaving. If you're looking at the image from left going to right, it's almost like if you're walking up this line, you see. You're walking from the left going to the right. If you look at the graph of f, right, from the left side, you can see here you're going to be walking upwards all the way until the turning point. The moment you get to the turning point, you're now going to be walking downwards. You see, you're going to be walking downwards, 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 downwards.
Then upwards again.
And then upwards again. Yes, madam. Yes, you are 100% correct. You. Look at you. Look at you. Yes. So every time you're walking up, that's where the graph is increasing. Every time you're so let me write also increasing. Every time you're walking down, that's where the graph is decreasing. They want where the graph is increasing only. So as we already know that the x value is here, right? The first x value here, we got it as 4. The other one was negative 2/3. So you can see the graph is going to be increasing where your x value is between negative 2/3 going to infinity. So it's going to be from negative infinity all the way until negative 2/3. That's the first portion. And then we're putting a round bracket because specifically at negative 2/3, it is specifically at negative 2/3, the graph there has a gradient of like 0. So it's neither increasing nor decreasing. So that's the first answer. Then here we're going to say, or our x value is an element of positive 4 until positive infinity. Like that.
I wrote nonsense game.
It's okay.
Because
okay,
okay.
That's okay. That's okay. That's okay. That is okay, madam. That is okay. 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 So, anyways, the next question also, we have to make use of this picture here. Let me see, paste. So this picture here, pardon?
No, I'm talking to myself, sorry.
Oh, nice. I think you needed, it sounds like you needed expert advice, you know, so you had to consult somebody capable. Excuse yourself.
No, I mean, like 8.5.1, I wrote where x is greater than -3. Like I used the value of x, yeah, a.
Yes, apologies, madam. Apologies. But anyways, you see the next question here. You see the previous one where the graph was increasing or whatever. We had to make use of the turning points. With concavity, I shouldn't do this. With concavity, we have to make use of the point of inflection. I had made it go through here, but it's not guaranteed that that's the point of inflection. The point of inflection is just the point exactly in the middle of our graph. So we actually only need the x value of the point of inflection. Fortunately, the x value of the point of inflection, it's always in the middle of our x values of our turning points. So you see the middle of this and this, you can just say -2/3 plus 4, the whole thing divided by 2. That's how you get the middle of those two values. So what does that give us in the calculator?
Mm. 5/3.
5/3. 5/3. There we go. Let's see here. So the x value here is 5/3, right? 5/3. So if you're going to now work out where a graph is concaved up or down, you have to remember that the one side of your point of inflection, if it is like frowning, it means this side is the side that's concave down. The side that's frowning is the side that's concave down. And then the side that's smiling is the side that's concave up. You see? Yeah. So when you're answering your question, they're asking you, where is it concave down? Concave down, where our x values are from -infinity up until 5/3.
So, sir.
Mm-hmm.
So please repeat the part where, like, why did you use the -2/3 plus 4 divided by 2? Like, what were you looking for?
Okay, so we were looking for the point of inflection. Point x value of the point of inflection. Yeah, the x value of the point of inflection. So since we wanted the x value of the point of inflection, that's one way to do it, you see. The other way to do it is to use the second derivative, you see.
Oh, yeah, I'm used to that one.
Yeah, so that one we would take, we have the first derivative here already, right? Somewhere, where is this thing? Up here somewhere. So if you take the second derivative here, the second derivative is like 6x minus 10. And then if you solve for x here, you can see the 10 goes to the other side, it becomes a positive 10. And then if you divide it by 6, you're going to have 10 over 6. And then if you simplify it, you're going to have 5 over 3. You see that? Yeah. So that's just to give you the idea that you see, even if you don't have the equation of a graph, you can still work out the point of inflection if you need to. You see? Because the point of inflection is literally just the middle of the whole image of your graph. So for example, right, it says here in the figure below, A, B, E. So there's A here, B here, E over there. They said it is a triangle, it has a base that is X meters. And then it says the base and the perpendicular height of the triangle add up to 10 meters. So this sentence is important because you don't want to just let these kinds of information slide. They said the base of the perpendicular, the base, which is this distance here, so it's X, right? And the perpendicular height, which is H. So what we already know is just from this statement here, they're trying to tell us that X plus H is equal to 10. You see, that's important because now we have an equation which will allow us to write one of these variables as the subject of a formula. So here it says the triangle is mounted on a rectangle which is BCDE. And then it says here which has a perimeter of 32 meters. So again, you see, we want to know what these kinds of words mean. Perimeter, we know it refers to the different sides of your shape added up. So the length here, which is X, right? What we know is if this is X, this is automatically going to be X. And we don't know what this is, but we know it's equal to the other side over there. They told us everything adds up to 32. So what we already know is the 32, right? I mean, this side here, the BC and the DE, we don't have any value for it, but we can write BC and DE in terms of X. We can do that because firstly, what we know is 32 meters, right? That's everything together. So if you take 32 and you minus X and you minus X again, whatever you have left is what BC and what ED is. Or rather, you can just put it this way, 32 minus 2X, right? If you take 32 and you remove 2X, what you're left with is these two put together, you see. So the distance of BC plus ED, right? What we know is 32 minus 2X. This is what BC and ED is equal to. EC and, I mean, ED and BC put together is equal to 32, which is the whole thing, minus 2X. However, we know that BC and ED are the same. So what we can say is the length of BC and the length of ED, right? It's just going to be 32 minus 2X divided by 2. If you simplify this, you're going to get 16 minus X. So what we can easily do is, we know that this side here can be written as 16 minus X. This side here, we can write it as 16 minus X. Now, don't take for granted the fact that we are still talking about this description and we haven't even read the question yet. That's normally how you want to go about it, you see. So in terms of what's normal, it's easy for us to look at a sketch and then look straight at the question without even looking at the description. But then, I mean, obviously, if we're going to answer a question, we're eventually obviously going to look at the description. But the thing is, the description is something that is too underrated, in the sense that, you see now, if you're going to now read this question, show that the area of the figure A, B, C, D, E is equal to this expression. The one thing is that this entire value here is meters squared, right? Which is fine. But then this entire value here, there is no other variable except for X. So already you want to know, okay, fine, the area of this shape is not going to be difficult to get. And you already saw that whatever we did here, we already know that the area of this shape here is just length times breadth. But then before we can work out the area, we have to at least, give dimensions to our different sides. So that's how we were able to see that, okay, we have to get a side here. And you saw we didn't do anything crazy. We just used the information they gave us. 32, which is everything, minus 2x, which is 1x and another x. If you divide that by 2, you get one side, which is also equal to the other side. Now for the top shape here, the area of our triangle, we already know it's half base times height. Now the issue is our expression here only has x as the only variable. So whatever we're going to do, we need to make sure that our values or whatever we write down, the only variables there have x in it. So our base has x, which is simply x, but then our height, we have to write it in terms of x, you see. This is where this statement comes in, because this statement allows us to make h the subject of the formula, which we can write as 10 minus x, you see. So what this does is, in terms of us now getting our area of our shape, we already know that we have to get the area of the triangle, which we know is just going to be a half multiplied by the base multiplied by the perpendicular height, 10 minus x. And what we know is this, we just have to leave it as an expression, you see. This is just a half x, and then here 10 minus x, right? If you want to multiply inside, it's fine. You're going to have a half x here times 10, right? Which is going to be 10x over 2. Because remember, when you multiply a fraction with a value, you only multiply the top because the bottom has a 1. So this times this is 10x over 2. And then here, this times x is negative x squared over 2. And then, carrying on, we know 10 over 2 is just going to give us a 5. And then here, if you want, I mean, like 1 over 2 is just a half. Then you can have your squared there. So we have our area of our triangle. As we know, we should have gotten, we know we have to get the triangle. That one is straightforward. Same as the rectangle, we have to get the area of the rectangle there. So getting the area of the rectangle, as you can see, we're also not doing anything crazy. We're just doing something very normal. Length is just x, breadth is just this. Whatever you want to call the length or the breadth, it doesn't matter, you see. So here it's just going to be the 16 minus x multiplied by the x, because it's length times breadth. So this is just going to give us 16 times x, which is 16x, negative x times x is negative x squared. So what we know is that the area is going to be equal to this plus that, you see. So here 5x minus the half x squared plus this thing here. So fortunately, we don't have to put any brackets because we're plussing, So adding these together, now we can just use our calculator. So here I have to be careful because I'm seeing, you see here, there's a negative 3 over 2, and it's coming from this minus that because these are like terms. Negative a half minus 1 gives you negative 3 over 2x squared. 5 plus the 16 is going to give us a 21x. So you see, the closer we got to the question, the more we started making use of this to see if we were on the right track. For 3 marks, it says here, determine the value of x, right? For which A, B, C, D has a maximum area. So this question, it's obviously one of the easy ones because as long as you have your area formula in terms of x already, you're good to go. Because these kinds of questions, all they require you to do in terms of you getting the maximum area or the value of x for which this has a maximum area, you have to take your area equation, right? Your area equation is already in terms of x, which is good. So this area equation, for us to get the value of x for which our shape has a maximum area, we have to differentiate once, and then we have to make the equation equal to 0. So differentiating once is 2 times this thing here. It's like negative 6 over 2x plus 21. And then, I mean, if you want to simplify, you can, but we don't have to. So once you've differentiated, you just need to make your equation equal to 0, and then you solve for x. So this is just actually a minus 3. And then solving for x here, 3 can go over to the left. And then we can divide both sides by 3. divide by 3 here, divide by 3 here. Our value of x is equal to a 7. So what that is telling us is if we throw x as 7 here and we throw x as 7 there, that is going to result in the highest possible area. If we throw x as any other number, that's not a 7, we're going to get a value of our area that is lower than what we would get if x is a 7. So for 9.3, right? For 9.3, what we know is that for 2 marks, it says here, hence determine the maximum area. So here you see that the link here is that this one is asking us for a value of x that results in the maximum area. This one is asking for the actual maximum area. So meaning for this question in the area equation, we are going to throw in our value, which is a 7 there. Wherever x is in our area formula here, we're going to throw in the value 7. And then we're going to get the actual maximum area. So let's see here, 7 over there, negative 3 over 2, 7 here, squared, 21 with the 7 there. So all this we have to put in the calculator. So 3 over 2, 7 squared, 21, the 7 over there. This is 147 over 2. So that's our maximum area. So it's like in decimals, it's going to be 73.5 meters squared. And then they're going to give us 2 marks for that. Question 10 here, we have probability. It says the following. In a surgery, 1,530 people are asked whether they had ever broken a limb. Then they said here, the results of the survey were as follows. Okay, so broken a limb, 400 people that have broken a limb, people that have not broken a limb, and then the totals here, right? So here we have males, and then we have females, and then we have the totals. So yeah, quite interesting. So here it says calculate the values of A, B, C, and D. So this is not too difficult. We actually just need our calculator because remember from left to right, the totals add up to these numbers. So here we know whatever this is plus this should give us 732. 782. So 782, if you remove the 463, you should get a value of B, which is where this 319 is. So with that 319, right, what we already know is the following. We already know that with 319, it doesn't matter what you want to do next. A, C, or D, it really doesn't matter because from top to bottom, everything adds up to the bottom number. So the 913 here, if you remove the 463, it should give you a value of A. So let's see. 913 minus 463, that's going to give you 450. 450. Here you can do the same. This minus that gives you the value in the middle over there. So that's like 617 minus 319. This is giving us 298. Moving on, same here. This minus the value right at the top there will give us D. So 1530 minus 782. This is giving us 748. There you go. So with that being said, what do we now need? We have our 4 marks. We can now move on. Moving on here, it says, in this 2-mark question, they said if a person is chosen at random, what is the probability that there will be a female who has a broken limb? So the probability of that happening, right? The one thing we want to keep in mind is in total, there's 1,530 people. So all we need now is to find out the number of females that do not have a broken limb. The number of females that don't have a broken limb, it's 298. So we put 298 at the top there. So this is the probability that if a person is chosen at random, they will be female, and they won't have a broken limb. So that value in the calculator, you can just get its simplest form. That's going to give you 14765. So let's just do that. 14 over 765. There we go. So moving on to another 2-mark question. This 2-mark question says 2 learners are selected at random from a group of 10 boys and 12 girls. So a group at 2 learners are selected at random from a group of 10 boys and 12 girls. Determine the probability that they are both girls. What? I feel like I read this question without even being in my mind. I'm literally somewhere else and I'm reading the question. So 2 learners are selected at random from a group of 10 boys and 12 girls. Determine the probability that they are both girls. So for 2 marks, we don't want to overthink this kind of a question, because this is how you're going to do this. You ask yourself, in total, how many people do you have? You have 10 plus 12, right? 10 plus 12 is giving you a total of 22 people. So the idea is, when you will be choosing the first person, in total you have 22 people. So you ask yourself, what is the probability of choosing a girl? The probability of choosing a girl when everyone is still there will just be 12 over 22. This is when you choose the first girl. When you will be choosing the second girl, right? Firstly, remember, you now only have 21 people. Now, say you chose a girl the first time. It means that amongst the girls, you only now have 11 of them, you see. This is what you want to think. When you choose a person for the first time, the chances that you choose a girl is just 12 over 22, because there are 12 girls and there are 22 people. But now, when you will be choosing another person, the chance that you choose a girl again, remember, 1 is gone now. So you only have 11 girls, and you also now only have 21 people. So this is the chances of you choosing a girl on the second try. This is the chance of you choosing a girl on the first try. So the probability of these 2 scenarios happening, you just multiply them together, because the probability of you getting both girls is going to be this value multiplied by that value. So in our calculator, 12 over 22 multiplied by 11 over 21. That's going to give you 2 over 7. 2 over 7. You get your 2 marks and you keep it moving. For 3 marks, it says here, what is the probability that 1 is a boy and 1 is a girl? So we use the same idea. In the beginning, there's 22 people. Oh, wait a minute. This one we have to be strategic, because remember, let's do it this way. 1 is a boy and 1 is a girl. Remember, there's a scenario where, say you choose a boy first. The chances that you choose a boy first, you have to think to yourself, firstly, there are 10 boys, right? So the chances that you choose a boy first is just 10 out of 22. Now, once you have chosen a boy, the chances that you choose a girl, there's 21 people, right? And since you chose a boy the first time, all the girls are still there. So the chance that you choose a girl is just 12 over 21 people in total. This is if, let's say, you choose a boy first, and then if you choose a girl afterwards. So this would be scenario number 1. Whatever this is, we'll find out just now. So this is going to give us the probability that we choose a boy first and then a girl afterwards. But then, them telling us we choose 1 boy and 1 girl, it doesn't mean that it has to be specifically in this order. Remember, we can choose a girl first and then choose a boy afterwards. So say we choose a girl first. Choosing a girl first, we know that there's 12 of them out of 22 people. The moment you choose a girl, we know that the probability of you choosing a boy the second time, we know that all the boys will still be there, right? So you still have 10 boys here but then you only now have 21 people because a girl was chosen the first time. So we know that these are the two scenarios that can play out. You choose a boy first and then a girl, or you choose a girl first and then a boy. Those are the scenarios, you see. Let me actually write them out here so that they are a bit clearer, you see. You can either choose a boy first and then a girl afterwards, or you can choose a girl first and then a boy afterwards. You see, those are two scenarios that can happen if you choose one boy and if you choose one girl. So us knowing that, we need to keep in mind that whatever this is, it's going to give us an answer. Whatever this is, it's also going to give us an answer. So the probability of one boy and one girl will be these two numbers put together. So let's put those in the calculator. 10 over 22 times 12 over 21. So this is giving us 20 over 77. The bottom part, we have here 12 over 22 multiplied by 10 over 21. So that's going to give us, again, 20 over, what you may call, 77. Well, that's just a coincidence. So the 20 over 77, we have to add those up together. So this is going to be 20 over 77 plus 20 over 77. This is giving us 40 over 77. So 40 over 77 is the probability that we get one boy and one girl. It doesn't matter which one you get first, but those are two possible scenarios, and you have to be careful of them. This is one of those questions where if you drew a tree diagram beforehand, you will still be able to get these same answers here. So that's for 10.2. Let's see if there are any questions. Nope. With the next one, we have a Venn diagram. This Venn diagram says the following. In the Venn diagram below, M and N are independent events. So there's M over here, there's N over here. So they say they're independent events. What you have to remember about independent events is that the probability of A multiplied by the probability of B will be equal to the probability of A and B. So if these are independent events, what you know is the probability of M alone, I mean the probability of M, right, is these two put together. The probability of N is these two put together. Because remember, for M, you should consider the whole thing here. And then for N, you should consider the whole thing here. Like this. Woo! I thought I was drawing a perfect circle, but I was like, nope. Let me just see here. Yo. Ish. Whew. Okay, there we go. It says you calculate giving answers correct to 2 decimal places. The value of X. Getting the value of X here for 3 marks, we don't want to overthink it. We just have to make use of this law. The probability of A and B, the probability of A times the probability of B is equal to the probability of A and B. We can actually just rewrite this using our two events here, event M, event N. So this is, we can clearly say the probability of M plus the probability, multiplied by the probability of N is equal to the probability of M and N. So these pieces of information here, the probability of M is going to be these two put together, which is X plus 0.12. That's what the probability of M is. The probability of M is just X plus 0.12. The probability of N is just 0.45 plus 0.12. And then the probability of M and N, the probability of M and n, according to our Venn diagram, it's just 0.12. That's a 0.12 over there. So with all this being said, right, clearly we can see that we can easily get our what? We can easily then get whatever they're asking for, which is x, using this formula. So where PM is, right, we know that you can easily say the whatever this number is. Let's see, this is just where PM is, we know it's just x plus 0.12. And then where PN is, it's this number. Let's just put that in the calculator. 0.45 plus 0.12. That's just 0.57. So let's put here 0.57. And then, so this here, which is this, multiplied by this, we know it's equal to this value, 0.12. And then we can just solve for x. Solving for x here, we can clearly see we can just divide by 0.57 first on both sides. If we're going to do that, this can cancel that. And we have x here plus 0.12. And then here 0.12 over that, we're gonna have the 4 over 19, right? So let's do that. 4 over 19. So this can then go over to the other side. I don't know why I didn't just put this as a decimal. I didn't put it as a decimal because 4 divided by 19 as a decimal is just like this really long number. So we can just leave it as 4 over 19. So 4 over 19, we're going to remove the 0.12, and then we'll have our value of x. Let's see what our value of x is. 4 over 19 minus 0.12, we're getting the 43 over 475. 43 over 475. So with this kind of equation, I would much rather leave it as a fraction, because at least your fraction has, it's complete. If you round it off, you would have rounded it off to like something like 0.091 or 0.1, which may not be a very good idea. So a fraction is best. Getting a value of y here is not a problem. Fortunately, getting a value of y is quite simple, because remember, in a Venn diagram, everything, the Venn diagram gives an idea of how everything relates to each other. So because this Venn diagram is already talking about independent events, what we know is in probability, all your different events, right? The different probabilities of your different events, all of them put together to give you a 1. So meaning the probability of M alone is this value, the probability of M and N is this value, the probability of N alone is this value, and then the probability of neither one of these two, this is where Y comes in. So since these are all just different probabilities, everything here put together should add up to 1, meaning X plus this plus the Y should add up to 1. So here, if you look at it nicely, right, we are going to have here, we said this was just 43 over 475. 475. So 43 over 475, that goes there, this goes here, this goes here, and then this is Y. So everything we know it should add up to a positive 1, because in probability everything should add up to 1. So we can just do that here. 43 over 475 plus the 0.12 plus the 0.45 plus the Y, this should give us a 1. Now to get Y, clearly we can just add all the numbers together first and then move them to the other side. So this is 43 over 475 plus 0.12 plus 0.45. Everything put together there is 251 over 380. It's like 251 over 380. Now where this is, we can move it to the other side, right? Y is equal to 1 minus 251 over 380. So here, therefore, y is equal to, let's see what this is giving us. 1 minus the answer. This is equal to 129 over 380. And that's the way we like it.